get going because it's already 5:20. Just a heads up. 6:45 we'll take a break, and at 8 o'clock we'll take a break. So those are the 2 breaks we're taking. Yes, yes, we will take a break for it. So today, of course, we're going to talk about ECN. We're going to talk about the 4 chapters on the exam tomorrow, which is going to be mutually exclusive projects, replacement decisions, depreciation, and inflation, which are 4 of the final chapters in the course. Heads up before we start, ECN is not my strongest class. I can probably answer a lot of the questions, but I probably won't be able to explain things as well as I can in other classes, but sometimes I just know one way to do things, and I don't particularly know why it works, but it does. And anyways, but we'll try, we'll figure it out together. Yeah, it's all good. Yeah, okay, good. So yeah, also I posted new notes on my website. I'll put it here in homework help for ECN. I just now posted like within the last 5 minutes. I posted a new version of it. So if you had one from before, this new one has much more updated stuff. I haven't proofread it for typos, so it's not. I can't say it's finished, but it has all the content. I'm pretty sure, except one thing, which I'll mention when we get to it. So there you go. I posted it in homework help. So if you want to go there, you can. There's the website, and you can find it there. So yeah, news. Those are all just now. I posted new ones that are updated fully. Okay, so I think the idea was that I was gonna start. My idea was that I was gonna start with Toksoy's practice midterms. Does that sound like a good place to start? And then if we have that kind of is gonna give a general overview of everything, and then after that, if we have trouble with more specific things, then we can go into the chapters themselves and the practice questions there. So does that sound like a good starting place? Toksoy's final exam practice questions. Okay, then that's where I'm gonna. Okay, then let's start here. Yeah, I haven't seen those yet, so yeah, those would probably be good. Okay. Sure. Yeah. That's true. Yeah, we can do the quizzes. We could do the Toksoy's quizzes as well. I've been doing that to practice. I've been doing the quizzes again. Because, yeah. Okay. Well, they're all marked, and he posted the answers, so. Right? So yeah, it's all good. It is, yeah, and probably more related to the test questions. Yeah. Oh, okay. I'll make it smaller. That's good. If I fixed it, okay. Well, that's yeah. Oh, I am recording, but your voice is not in it for some reason. Let's see why.
I feel gravely hurt.
Okay, now it is, I think.
Okay, good.
Okay, good. Yeah. No, maybe it was already, and I just didn't realize what I was doing. Okay, anyways, it's fine.
Okay.
Okay, let's start here. So you have purchased a machine costing $40,000. The machine will be used for 2 years, at the end of which time its salvage value is expected to be $1,000. The machine will be used for 5,000 hours during the first year, 1,000 hours during the second year. The expected annual net savings will be $20,000 during the first year and $40,000 during the second year. If your interest rate is 10%, what would be the equivalent net savings per machine hour? Okay, so I got to open up my notes a little bit here for this. So what do we know? Let's see. So net savings per machine hour is what we're looking at. So I think what we got to do is find the net saving. Well, let's see. What do we know? So first year, what do we know about the first year? Is that our savings are first year is $20,000. Oh, my pen's on the wrong size. $20,000, and the number of hours that we go is 1,000. Okay, 1,000 hours. Then for the second year, it's 40,000, and no, sorry, it's 500 for this one, and then 1,000 for the next one. Okay. So, if I want to find the equivalent net savings per machine hour, then we find the equivalent savings per year, and then divided by the machine hours. Would that just be? Would I find the net equivalent? Yeah. So this is what I think I do. I think. Let's see. So I'm pretty sure what I do. Let's see. I'm going to find the present worth of these two savings. I don't think I take into account the cost of the machine, because that's not part of the savings.
I think you should. Like
think I
the
should?
cost and the salvage value. You bring them all to the present,
Yeah.
and
So
you see that, and then just distribute them across the year, and then you will find the yearly.
that's not part of savings. My confusion is just that that's not part of savings, because savings.
Yeah,
are...
is this like a units of
Finding-
production thing?
You find how much you save after the cost. The cost is also included in the, like in the net diagram, the line.
Yeah.
Yeah, the thing, or the thing that he draws every time. Forget what they call it.
The cash flow diagram.
Cash flow diagram.
Yeah.
Yeah, you might as well make that.
Okay, might as well.
I have so from Toksoy's lectures, coincidentally I was reviewing this right before this, and we have a very similar question from it.
Okay.
And it's probably I'm sending a screenshot in homework help so you can see kind of how he went about doing the question.
Mm-hmm.
Because I did not think to do it this way. But
Yeah. Okay. Sounds good. Yeah.
But it's different from when you don't have. It's different when you don't have the same amount of hours each year.
I see.
If you have the same amount of hours, it's quite easy to do the calculation. But when you have different number of hours each year, it complicates the calculation a little bit. Not a lot,
Yeah.
but just a little.
Yeah. Okay. Let's see what he did here. So, 1,500 uniform annual savings is the C 1,500 uniform annual savings. Let's see. Let me put the solution up here. Well, this is not the same solution as for the same question, but it's similar.
As I'm thinking right now to solve it, I would just bring everything to the present, like to year zero, distribute it across, like to find the annual cost of it. And then I will just find the average hours in the 2 years. So I will add them together, divide them by 2. That's how I think. I think it could be wrong as well. And then just divide that by that. Divide the annual cost by the average hours used. That's how I'm thinking of using it. Like
annual equivalent net savings. So annual equivalent. I'm looking at the solution now, of course. So there's the capital recovery, which is the A given P, and then 10,000. 10,000 is what? 10,000 is the salvage value, which is times 10%. Let's see. That's not quite what's happening in the solution here, and I also can't understand the solution here. So, okay, we're starting with a tricky one.
Starting with the doozy.
Rough start.
Rough start, but that's okay. I can move
I read
Which
it.
question is it from? Sorry, where is this from?
Just from Toksoy's practice here. I'll put the solution here, but his solutions usually don't make sense, so I don't know how helpful it's going to be.
I solved that one already, and what I did was I don't know his name, but what he was saying, I took everything to the present.
Yeah.
And the present worth, then divided into the respective years by finding the amounts, and then just using the when you use C times hours times the thing what you make in each year, and then I just equal it to, like, I think the present worth. Like, I did it how the other guy was explaining it.
Or maybe you can do 200K and then divide by number of hours and then move it backwards, and then do 500 hours and then do 400K divided by 1,000 and then move it backwards, and then maybe take that and add them all together and annualize it. You know what I mean?
Yeah, I see what you mean. But like, I'm getting 3 different strategies at the same time. So yeah, let's do one at a time here. Yeah, that's the cap. What is the? I'm confused about that SI percent. What is the SI percent? I thought the capital recovery was.
So there's 2 equations for the capital recovery cost. I sent the second equation. I should probably send both of them if that makes a little bit more sense.
Yeah.
In homework help, I sent both the capital recovery cost equations. I find the first one a little bit more intuitive.
Yeah,
But
I don't even understand what I never even like. I think I've seen the second one actually, but I don't understand the second one.
I don't understand how it works, but it just does.
Okay, let's use the first one
what-
because I feel like a given p.
It's more intuitive.
Yeah,
I believe
I think
sometimes magic is involved in this course.
what's involved in this course?
In magic,
Oh,
like
some magic.
they,
Yeah, yeah.
they just put the right answer there. You follow the same steps. You don't have the right answer.
Yeah. Let's make the let's do the capital recovery cost here for these two things. So I'll bring this one back to oh yeah, someone has the solution here. Oh yeah, it is the solution for it. Yeah, okay. So let's do the capital recovery. So it's going to be 40 or no, capital recovery is with the 40,000 is what I said. Wait, it's $40,000 in savings and it was also $40,000 machine? Yeah. So $40,000 that's a payment, so that's going to be the negative one. Or no, that's not going to be the negative one. No, because it's capital recovery is the payments. Okay, $40,000. A given P, what was the MAR? 10% for 2 years minus the salvage value, which was 10,000. A given F, 10% for 2 years. Yep, that makes sense to me. So that's the capital recovery. That's the yearly amount there at 10%. So then from this, I'm going to take the savings back as well. Let me look at the solution here. Let me look. Ray sent a solution. So I want to see what this is. Yeah, so this is what I drew. It's a $50,000 one, I percent. So they do the capital recovery, which is some amount, which we can do. The annual equivalent is P given F. Yeah, annual equivalent, we just find the annual, that's fine. The annual equivalent is that. Net savings. I think the word net savings is what's confusing this a little bit. So the solution seems to be find the capital recovery, find the annual equivalent cost, these two things, okay, which is going to be the $20,000. Well, I'll just say 20,000 P given F 10% 1 plus 40,000 P given F 10% 2, and then do A given P 10% 2, and there's our annual equivalent savings. Those are all savings.
Wait, wouldn't it be A given F again since it's for 1? Like, because is that how it works? But it just be for 2 years? I don't know.
What part?
For,
This last
oh,
part?
no, never mind. I mixed it up.
That's
yeah,
A given
it makes
P.
sense.
Yeah.
So,
So that's our annual equivalent savings. Yeah.
yeah, I just used the way that I said, and I got $15 per hour used. That's
Yeah.
close to what the answer is 15.2. Is that just a coincidence or I don't know.
I don't know. Let's see. Yeah, 15.2 does seem to be the answer. Yeah, I see that.
I got just 15, like 15 play.
And then so the main part here is that this annual equivalent net savings is the capital recovery, not credit recovery. So the capital recovery minus the annual equivalent. Sorry, other way around. Annual equivalent.
Isn't there an issue of the fact that the machine isn't running the same amount of hours each year, so you can't exactly divide it up equally?
Yeah, you're right. But we haven't even included the hours just yet, right?
So far it's the same, no matter if they had the same hours or not, right? So far.
So far it's the same. No matter
Okay.
the hours haven't been taken into
But
account.
hours are relatable. Like it worked at double, but it's also made at double in profits.
I don't know. I remember seeing a question like this, and you do get a function like it's
Yeah,
like solve for
you'll be solving for C, basically
Yeah.
the same way that we just calculated the annual equivalent savings. You do the annual equivalent hours, carry over whatever variable you would like to name it with the equivalent dollars per unit effectively, and then you solve for C using this value that you solved for here.
Yeah, yeah.
Oh, that makes a lot more sense. Okay.
So
basically, it's like, okay, sorry.
Go for it.
No, I was just saying, I think from what I remember, the always are also like you have to do some kind of calculations that kind of replicate the P given F. It's like putting it in terms of like a monetary value, but it's time. That's all I'm saying.
Yeah, because 5,000 times something is going to be an amount of money, right? Is going to be the amount of money that's the savings per that machine, right? So 500, not 5,000. 500 for this year, and 1,000 for the other one. Times something times some C is the monetary savings per machine hour, right? So yes.
Sorry, I just wanted to ask, where are you pulling the questions from?
This is Toksoy's practice exam. Toksoy's practice exam.
Good old Toksoy.
The way Grovitz did it, he just did all of this at once, and like he did like I can't speak, present equivalent costs. So he would like take this 40,000 as a positive, and all money or all savings that you make would be negatives, and you just subtract that from the present value. You put them all in present worth, or you could do like annual equivalent cost, and then you just solve for C that way.
That's essentially this. I just haven't included the thing. Yeah, I can't actually see how where does the net savings come in, because
I'm fairly certain that savings and annual equivalent worth are similar.
Profits to the machine and the salvage value subtracted from the cost, and whatever it's left, that's your net saving. It's just revenue minus cost, isn't it?
Your net. That's what I'm saying here, right? This is minus the capital recovery, right? And then exactly. So then the next part here is the annual equivalent savings. So what they did is, the annual equivalent savings is going to be the C times 500 for the first year, right? So I'm saying C is our answer. So it's the equivalent net savings per machine hour. Savings per machine hour. So savings per hour, right? Mm-hmm. And that's what we're looking for. And then that's equal to the C500. Right, times 500 for the first year, and I'm going to do P given F 10%. What was it? 10%? 10% 1 plus C 1,000 P given F 10% 1 2.
Is it 2? Isn't the entire thing in brackets again? Because you take it.
And then we're going to take the annual equivalent worth of this. So A given P 10% 2, and then we know this. We know that the annual equivalent, say, I don't know why it's called savings in the solution still. That doesn't really make sense. But just the annual equivalent with that amount, that's going to be equal to our net savings here. That's going to be equal to our net savings. So I can just set this equal to each other. I can set C500 P given F 10%. Well, I'll just just copy it. I'm not going to write it all over again. Okay. So I take this one, and I set that equal to the annual equivalent minus capital recovery, because both of these are our annual net savings. So this should be also net. This is just savings, you're right. But yeah, these are equal. So then I can solve for C now, essentially. Right? I can solve for C. Pretty sure I can just factor out the C from this. Yeah, why not? Why wouldn't I be able to? Yeah, I can factor out the C. So I can say C annual equivalent minus capital recovery over, someone's got their mic on. Could they mute? Thank you. 10% 1 plus 1,000 P given F 10% 2. All that A given P 10% 2. So let me just do all this underlined here. AE minus CR. And then you just plug in all the numbers to figure out what this is. AE we set up here was the annual savings, annual equivalent savings. Capital recovery is capital recovery, which is the investment.
Capital recovery is 27,810.
Okay, yeah. Salvage. sorry, 27,810.
Yep, that's what I got.
And then annual, yeah, I think that's. Oh, hold on, that's not what it is here. Oh, because they used the other formula, which I thought was equivalent to this one.
Excuse me.
I did the other way and I got the same answer. I don't know. I don't think it. Yeah, I got. No, I didn't get 27,000. I got 18.
What is the actual answer to this question?
The
like
actual
the answer.
The C.
Yeah. Yeah.
$15.22. $15.22.
Oh, okay. This is done in a weird way. So
tell me.
What do you think this formulas? You're solving for C.
You're equating. Basically, think of this
Did
like.
you find the annual?
Guys, one at a time. One at a time. Someone's explaining.
So you can basically equate two cash flows together. One of your cash flows is disregard anything that has to do with hours.
Yeah.
Because you said 50. You said it was 15.22, right?
15.22.
So disregard anything that has to do with hours. You have a present worth of negative 40K. You have you have a cash flow of 20K. You have a cash flow of 50K, right? Because there'd be the salvage. Well,
okay,
be 40 plus the 10,000.
You're right. Yeah.
You could also do this, like you could turn it into a CR and just find the difference.
Essentially, that's what this is here, right? That's what this.
So what would be the present worth of this? Would be negative 40K plus 20K over 1.1 plus 50K over 1.1 squared. That's going to be has to be equal to what you have there.
Yeah.
Where you see how you wrote C over, or you put P given F, but it would be C times 500 over 1.1 plus C times 1000 over 1.1 squared.
Yeah.
And then annualized. That has to be equal to the present worth, like the present worth of the, because it's an annual earning. Yeah. It's an annual earning, meaning earning like above your cost. So your annual earnings for those years has to be equal to the annual earnings that you had like overall. So it has to be equal to the annual equivalent worth.
Yeah.
Or not annual, sorry, the present equivalent worth.
Present equivalent worth. So
the present equivalent worth of the C's with the 1,000 stuff has to be same as the present equivalent worth of the minus 40K
of the net savings.
And
of the net savings.
Basically, yeah.
I did annual equivalent here, but yeah, you can do present equivalent, and that would be the same thing.
It makes, you can do either one. It shouldn't make a difference.
It shouldn't make a difference.
I chose to do.
Yeah, that's what we're doing here. I'll explain that I'll explain that again here. Although you did a good job, I just want to, because it's a confusing thing. So we have two different cash flows happening. The first one is this year 0. We have this cash flow with the investment. Here, I'll put it as a right one. Investment. Then we have in year 2 we get $40,000 and $10,000. So this is a 40,000. Sorry, we don't get 40,000. We get. No, we do. Sorry, I keep forgetting the numbers. $40,000 is from our profit, and we get what was it over here for this one? It was 20,000. So we get $20,000 here, and then we also get a $10,000 salvage. So these two cash flows have to be equivalent, right? These two cash flows have to be equivalent at any whatever present worth, annual equivalent worth. So what we're doing is we found the annual equivalent worth of this one, which is this net savings. Right, annual equivalent net savings, and then we're going to find the annual equivalent of this one, which is what this denominator is here, and then just solve for C. We're going to set those two things equal to each other and solve for C. So what C value needs to be done, what kind of savings per item need to be done, that's what the C is, and so it needs to be like achieved, and to make these two things true, that's what we're solving for. So any questions about this? Yeah.
Okay, so to get everything straight, so basically just kind of doing the same thing to both, but one of them is with hours and one of them with money.
Yeah.
And then one of the differences is that like one of them is the first one is like with hours and the second one is like with money.
Yeah, this is our time one. This is our time one.
Yeah, I will have to multiply C by the time to like equate it to money, I guess.
Yeah, because it's like that's like the dollars per hour. C is going to be a something in savings per hour. Right?
It's like a conversion factor, right?
It's like a conversion factor. We're solving for that conversion factor. What is the savings per hour?
So now we just have to like. So couldn't we just the same? Couldn't we just do it in present worth? So do we have to?
Yeah, you could do it in present worth. I just did it in annual worth because I was looking at the solution, but because the solution does it in annual worth, but annual equivalent. But yeah, you can do it in present worth and you get the same thing.
Would it be simpler or?
You get the same answer. You get the same answer.
And this is chapter 5, correct?
It's up to what, sorry?
So is this the same thing as those like simple investments, whatever things?
What's the simple? I don't know what's the
simple. It's not. You're not. This isn't a worth. We're finding an earning, which is it's a really weird, like way to do this question because it's not like we're finding how much worth are we making. We're finding. Ignore like if you were to subtract all of the costs that you had to spend to make this money, how much money are you making per hour?
So this is not the same as those like simple earnings or whatever question versus like simple investment versus non-simple investment. This is different. Correct?
I think I don't know what yeah.
Oh no, I was just saying for the first part, if anyone didn't understand the reason we did P given F and then A given P, if you wanted to clarify.
P given like so here P given F and A or up higher.
Yeah, any weird, any just typically.
Well, essentially, we're just saying these are two cash flows that happen later, and we're gonna bring them back, right? So this is like if I do a mini cash flow diagram, it's these two things, right? So this one brings this cash flow back to your 0. This one brings this cash flow back to your 0, and then we want to even this out. We want to find the annual equivalent savings, and so I'm just gonna do A given P because now we have a principal amount. This quantity is now a principal amount, right? Mm-hmm. And we're gonna do A given the principal 10% too, because now we have the principal.
Yeah. Also, side note, doesn't it feel like people who got taught like Toxoid versus Curve, it's just like two different courses? Like it feels like we're doing two different courses.
Honestly, you're not wrong.
Yes.
As someone that's had both profs in the past, yes, it feels like two different courses.
Yeah.
Okay. Like what's up with like I don't watch about him. I heard his name, but is he better or what's up with him?
Who?
Like
which one?
Like
they're different, and that's the.
Toxo is a lovable character, but I don't know if.
All right, guys, let's focus. Let's focus. Let's continue on ECN.
So, I guess I can plug in numbers into here and see what we get from this one. So, annual equivalent. I think Vikram said. Oh no, not annual.
I think my calculator was being kind of stupid. I ran the exact same thing again. I got 18,200.
Yeah, that's the number.
86.
86. Yeah, thank you.
Yeah.
And then annual equivalent savings. So this was capital recovery. So 18 to what was it? 286. And then annual equivalent is. Could someone do that? And I'll do the denominator here. If someone has it written down. 500 P given F 10% 1. I gotta find the tables, which of course I don't have open. Well, I guess I can do it here. 10%.
Okay, scroll up to the annual equivalent.
Yeah.
Real quick, I'm gonna take a screenshot.
There.
I'm only allowed to use the formula sheet and the factor table, right?
Formula sheet and factor table. I think that's right. Yeah. Times P given F.
We can use it online. We don't have to like print it or anything, right?
What'd you say?
Like we don't have to print it or anything. We can just like access it.
I'm not actually entirely sure, but probably we don't have to. Yeah, we don't have to print it. P given F 10% 2. I mean, yeah, we don't have to print it.
Okay. It makes so much more sense to cash flow diagrams. You know what I mean?
Yeah, I probably should draw them more. P given F 0.8264. Okay, and then. Okay, so the denominator here is, so annual equivalent is coming up, 18. So I'll leave this as CR. This was 18,286 over 738, and then Vikram, do you have the annual equivalent?
Yeah, I got it. It's 29,523.
523. So let's see. 29,523 minus 18,286 over what I just got. And yeah, 1522 is our answer here. That's correct.
Yay!
This question was worded specifically to make us fail.
Yeah, it definitely is the wording. Definitely
the
is the
earning
wording
part screws you over.
It's actually a simple question.
Is that like how many dollars per hour you save with the machine or something per year?
Yeah, it is.
This isn't a worth. This is how much money are you earning per hour? Not including like after you take it out all your costs. How much are you earning per hour?
Yeah, that's like better way of thinking of it than savings, right? To think of it as this is a revenue that you're getting per machine hour, right? You're getting a revenue of $2,000. You're getting a revenue of $4,000, $40,000 in this year. For this many hours of work.
Does mean that
There's too many people talking. One person at a time. What was it?
I'm sorry.
As I'm saying, don't you mean net income or whatever, not revenue? Like, because it's like at the end of the day, you're earning that much, not like earning.
No, I think it is revenue is right. I think revenue is right because this is like in this cash flow diagram here, we're treating it like a revenue, right? We're getting a revenue C times 500 as a revenue, 1,000, and then we're equating that. That's equivalent to this cash flow, the whole cash flow here.
Yeah, that's the net revenue. The revenue is what you gain. Net revenue is what you gain minus what you lost.
What you pay,
yeah. And also, you have done this question both with present worth and future worth.
And annual equivalent worth, yeah. And any of those three work, yeah. It's the same thing. It's just a different way of looking at it.
And like okay, maybe I'm missing something, but like, why couldn't you just like use the numbers? Like, why couldn't you just do 20K divided by 500 to find like the C? Because isn't C just like how much money you earn?
It's just that would get you the C for that year, right? That would get you the C for that year, and then you'd get a different C for year 2. But what we want is the C for the whole year, for the 2 years combined.
So couldn't we just I'm guessing, I don't know. So couldn't we just do C for the first year, C for the second year, and then annualize those? Or that's not how it works?
Erwin, we're not finding a worth. We're literally finding an earning. We're finding like how much am I earning, not like how much money is coming in. It's how much on top of all my losses am I making. So it's like
C is not something you can bring back to year 0. C is not something you can move back and forth. It's a rate that adds to.
Wait, C can't be move, but then but didn't we just do that? Didn't we move C around like with the hours when we did that, or no? Because
C is not being moved around. The amount of money that C times 500 is, and the amount of money that C times 1,000 is moved around.
So right? C times 500 is different than just C. C is just like a factor, and you can't move around.
C is $1 per hour.
C is a rate.
C is a rate. 500 is hours, so collectively these are dollars. Dollars can be moved around, right? Dollars per hour cannot be moved around because that's something different.
Okay. I was just a bit confused. I just want to get that out.
Okay, well, I'm happy we got through one question. Hopefully they're not all like that, so hopefully I didn't lose too many people there. But we'll see how it goes. So let's move on to question 2. You invest $2,000 in your.
Some of it again.
What'd you say? Blocking some of it. Yeah, I am gonna do that a lot. So.
Okay, it's okay.
Let's see that. Okay.
Yeah, that's good.
You invest $2,000 in your business, expecting to have a $1,300 net cash flow in the first year, and that cash flow in the second year. Based on the net present worth analysis, what is the internal rate of return for this project? Okay, so that's not too hard. So let's draw a cash flow diagram about what's happening here. So in year 0, we make a payment of $2,000. Then in year 1, we get a $1,000. Oops, oh my God, 1,000. I should be green, shouldn't it? $1,300. Then in year 2, we get $1,500. And so based on present net worth analysis, what is the internal rate of return for this project? So the internal rate of return is asking what interest rate do I need to get a net 0 to break even here? Right? So it's a good way to compare and make decisions is to know what that is. So let's find the net present worth of this, right? So net present worth is going to be, well, we have a $2,000 payment. They're going to add a $1,300 revenue. I'm going to move that back 1 year. So P given F, I, we don't know what percent, 1 year. I is what we're looking for. It's I star is really the internal rate of return. So that's the unknown we're going to look for. And then this, I'm going to add 1,500 P given F, I star 2. Yeah, move that back 2 years. And this is going to be equal to 0. So that's the point, is that we want to break even. We want the result of this to break even.
So I have a couple of questions.
Sure.
So I star is the same as IRR, the same thing.
Yes, I'm pretty sure. Yes.
And what's the difference between NPW and PW? Are they like the same thing, or like what's?
Yeah, I guess they're the same. There's a bunch of words for the same thing in this course. So yeah, net present worth, I mean, has an idea of like net. So you want to like you take the gains and the losses and the net present worth, and present worth maybe is more specific to just like one cash flow. So you do the present worth of each of these individual cash flows to get the net present worth.
Yeah, and also like Gravit said that it's a good idea to kind of keep things straight when you're just doing P given F and F given P, to just do 1 over I square or 1 over
I don't like doing that. I like to write the actual factors like this all the time, and then from there I start, because then if I start seeing different things, it just like to me it gets confusing, like what we're doing. Like it seems like
that's it.
But yeah, that's what I do. Okay, so I'm gonna rearrange this now. So now I'm gonna switch this to the formula. So present given final, that's like bringing it back. So it's gonna be, I'll rearrange a little bit here. It's gonna be 13 times 1 plus I star to the negative 1 plus 15 1 plus I star to the negative 2 equals 20, right? And then I want to solve for I, right? So it's pretty much doable here, I'm pretty sure. I hope so. If I factor out let's see. If I multiply both sides by 1 plus I star to the power 2, I would get 13 1 plus I star to the power 1 plus 15 equals 20 times 1 plus I star to the power 2. Then I want to move that around a little bit, factor it out, and I'm still going to run into...
This might be guess and check.
Yeah, this probably is guess and check. I mean, actually, no, I see what we're supposed to do. We're supposed to say
Question.
K equals, yeah.
Is there not like a percentage range?
For the answers? No, it doesn't give us percentage range for the answers.
Oh, okay.
So it's going to be minus 13k minus 15 equals 0. Plug this into a formula, solve the...
I don't know. They thought for my class, at least on the exam, most likely just gonna have to guess and check. So just like do the thing, like just try every range you give on the exam and just see which one.
And see which one. Yeah, exactly, and see which one makes the equation true.
I got 20 and 30 because I just guessed. Like I don't know what the range is gonna be, but I just got between 20 and 30. But try that out.
Yeah. So I got these two solutions for k. So let's see which one gives me one that makes sense. So k was, this is for k equals 1.25. So 1.25 plus 1.
Wait.
Yeah.
No, I was just saying, why if it's a variable in is it a what's that called again? Is it a revenue or a cost? Because then the negative wouldn't make any sense, right?
Which negative? Yeah, this negative.
Isn't that isn't there a negative right here? In the negative 0.6.
Well, this isn't quite the exact. This isn't the rate just yet. This is just like k that I'm getting from the thing here. So k equals negative 0.6. So negative 0.6 equals 1 plus I star. So subtract 1. Yeah. Well, it doesn't make sense to say that I star equals negative 1.6. So negative 160%. So this is our solution. I star equals 25%.
Yeah, like it just has to be between 0 and 100.
Yeah, you don't want to have negative 160%. So yeah, that's what I got. So this was done just with some turning this into a quadratic. But yeah, guessing and checking is also totally fine. Just, get your equation into something that's like kind of you can work with relatively easily. And then just plug in values in the ranges and see which ones make the equations true. One of them will, and that will be it. Usually you cannot solve for I star how I just did here.
Yeah. Could you just go through the question again though? Just really
sure.
quickly,
Yeah.
Kind of missed the part of it.
So you have 3 cash flows in this project. You have a $20,000 investment. Sorry, $2,000 investment. I'm thinking I'm going to make that mistake all the time today. $2,000 investment. You have a $1,300 revenue and then a $1,500 revenue. I'm going to bring... The question is, what's the internal rate of return? So what interest rate will get me a net zero profit, net zero everything, on this investment, on this, cash flow diagram? So I'm going to bring everything to the present worth and set the present worth equal to 0. So that's what I did.
Is that what the IRR means?
IRR is what rate of return is going to give me the net zero profit. Net zero everything.
Oh, okay.
So bring everything to the present worth, set it equal to 0, solve for I. The solve for I part depends on the question. Usually you do guess and check. Here I could actually solve it, but that's only a special case that I could solve it here.
Because the quadratic was simple. That's what you mean?
Yeah, because the quadratic was just doable even. Not even just it was just usually it's not even doable at all.
Oh yeah. Okay.
Or not by any methods that we know. So yeah. Okay.
Real quick, sorry. Could you do it by could you explain how you would do it by trial and error? I never really understood that. I always do it like a quadratic. Yeah.
Sure. So here, let's say I simplified the equation to this right here, right? And my ranges were, one of the ranges happened to be 24 to 26%. So I was like, okay, I'll try 25%. So just everywhere you see in this equation, like on the left side here, I'll say this is us trying it. The left side, plugging in 0.25, I get 13 times, oops, I'm in the wrong mode. 13 times 1.25, right? Plus 15 is 31.25, and I'm going to say that's equal to 20 times 1.25 squared, and I also get 31.25. So since I plugged in something to this equation for I star and I got left side equals right side, that's a solution. So 25% is a solution.
Also,
sorry. Okay, go ahead.
Another way to think about it for whoever asked is you can just move everything to the left side, so you can have 13.
Yeah, you can
1 plus I plus 15 minus 20 times 1 plus I squared. And then just plug in your range there. So you're going to have maybe 10 to 20, 20 to 30, 30 to 40. So just plug in 10, 20, whatever. And then let's say you plug in 20, it gives you, let's say 50. You plug in 30, let's say it gives you a negative number. The range where the top part and the bottom part, the top end and the bottom end do the sign change, that's the range you're choosing, basically.
Yeah, if you set this equal to 0, if you make the equation equal to 0, you just want to get as close to 0 as possible. So try to, if you have a higher interest rate and the present worth is going up, then you want to go down. You want to go down with your...
Yeah, hopefully they have. Yeah. So does that mean if at 25% in this case, that's when you make no money?
Yes,
that's what
that's the internal rate of return. Yeah.
Are toxoids finals multiple choice as well?
I think so.
Or do you have to enter a value? I'm assuming it's multiple choice. Okay, yeah. Then.
Rolik was gonna say something. Yeah, go for it.
Oh no! I think I understand. So pretty much, yeah. So pretty much when you equate it to 0, you have to get as close as to 0 and then the other way is you equate it to the 20 that you have right on the screen.
0 is probably a better way to do it though. 0 is probably is a better way to do it.
So.
Yeah. 0 is probably a better way. Okay.
I was going to mention a technique, which is if you assume there's no interest, is 20 greater than 13 plus 15? If it isn't, if 20 is smaller than 13 plus 15, you're going to need a large interest rate because you need to make 20 large enough to equate to 13 and 15.
Yeah.
if the left side is smaller than the right side, like without interest, then it'll be the opposite. You'll need a lower interest rate.
Yeah.
Okay. All right. Yeah, makes sense. Thanks.
Okay, good. Let's move on. So you are considering 4 cost reduction alternatives in your business. You have already had the information about the rates of return of these projects along with some incremental rates of return. So the incremental rate of return is like the difference between 2 projects. What is their incremental rate of return? So it's the rate of return of, in this case, it's the rate of return of this one minus the rate of return of this one. X naught denotes the do nothing alternative. The required investments are $420,000 for project 1, $550,000 for project 2, $720,000 for project 3, $800,000 project 4. MAR is 15%. What system should be selected? So I'm quite certain with this, we just sort of knock out cases about who should win. So essentially, all the MAR is 15% always, right? So if I look at my notes here, I gotta find it though.
Isn't it if IRR is, or like the rate of return is like bigger than MAR, and that's when you pick it, so you eliminate all the ones where it's like smaller?
Let's hold on one second. Let me find my notes here. I'll have it right here. So yeah. So if this is essentially, we're doing incremental analysis here. So this is essentially what we're gonna do. The MAR is 15% for all of them, and we're gonna use this criteria to decide which one's the best out of all of them, right? So if the internal rate of return of B minus A is greater than the MAR, remember MAR is 15% here. MAR is 15%. So yes, this is greater than MAR. Then we select option B. So that means that X1 won this one right here, right? Then between option 2 and the defender, right, or the do nothing alternative, I mean, this is also bigger, so we still choose X2. We're gonna get messy, but hopefully we'll try not to. This is still, we choose X3. Yeah, and here we choose X4. Everything's better than the do nothing alternative. That's what we've learned here. Everything's better than the do nothing alternative. Now, X2 is not better than X1. X1 won this one here, right? This one, X3 won, right? This one, X4 won, because it's higher than 15%. X3 won this one, higher than 15%. X3 won this one, lower than 15%, and X4 won this one. Okay, so now we got to compare what's going on in here, right? What should be selected? So we know that, okay, what do we know? We know that X3 is better than well, I guess we'll start with this one right here. X2 is worse than X1, right? Well, X2 is worse than X1. So let me see, what do we...
First of all, we know that do nothing is not an option because all of them are better than do nothing. So don't think of do nothing. That since we know that X2 is smaller than minus X1 is smaller
I think that means we can remove the X2.
Yes.
We can remove the X2.
I just do it like a rock, paper, scissors, and I just put them like all together in one line.
Yeah.
And see who won in the end.
Yeah.
I think X4, because it has the highest difference in the X initial minus X4, it has the highest interest. So that's what I'm guessing.
Yeah. So if we look here, if we look here, then so here, let me see the solution quickly. So if we compare now between these two, let's say between X3 and X4, right? Well, let's see where we're comparing X3 and X4 here, right? X3 wins, so X4 is out of it. And then let's compare X1 and X3. So where's X1 and X3? X1 and X3 is compared right there. X3 wins, so X3 is the winner at the end. So the idea is that we do this list, we make this list of who won each round, and then just write out the ones that won, X1, X2, X3, X4, and then just compare them one at a time. So X1 and X2, let's see, which one wins here? Which one wins here? X1 and X2. So these, they're being competed with here. X1 wins, so X2 is out of there. Right, then let's check, then, we're going to compare X1 and X3. X1 and X3 is right here. Which one wins? X3 wins, so X1's out of there. And now we're going to compare X3 and X4. That's going to be X3 and X4. Which one wins? X3 wins. So X3 is the winner again, I just did the question twice, but yeah.
Also, at the end, if you want to kind of like, if you get an answer, you want to kind of double check if you got the right one. You also like, you should get X3. In this case, you can see, does X3 ever lose? And if X3 always wins in every round, you also know you picked the right one. Because if it loses one, that's when you messed up.
Yeah, X3 shouldn't lose anything.
So basically, you compare the percentages, like with the preceding one, and if it's lower than 15%, it's like bad, right? In the sense that if you did x1 minus x2 minus x1 and it's lower than 15%, it's bad. But if you did like I don't know, x4 minus x3 and it's higher, is it better? Like I didn't really get
It's not really a good or
like,
bad
I get
thing.
a comparison.
Yeah.
Sorry, go ahead.
It's not really a good or bad thing. It's saying which one should you choose. So we're saying Project 2 and Project 1 are being compared. Right?
And they
Project
have 1%.
Their incremental rate of return, IRR B minus A, right, is we're going to compare that to the MAR, which was 15%, given to us as 15%. If that internal rate of return, so like for this one, let's say this example right here, x4 and minus x3, that's 14%. If that's less than the MAR, you select option A, the second one. So 3 wins here. So 3 is selected. That's why I wrote x3 here. But then, for example, here, x3 minus x1, that's bigger than the MAR. 21% is bigger than the MAR. So we choose option B, the first one.
Okay.
So this is why x3 won there too.
Makes sense. Thank you.
So my question is, the numbers on the bottom, do they mean anything? The investment ones?
They don't mean anything, no.
So it's just there to confuse you?
Yeah.
Yeah, because then they say in class that like the amount of money doesn't matter. It's just like the
That's just not what we're comparing. It's just not what we're comparing, right? We're not comparing amounts of money. We're comparing the incremental rate of return.
I see. Okay, thank you.
Okay, let's try the next one. Your company signed a contract to remove soil from government-owned property. This task requires a specific bulldozer to dig and load the materials onto a transport vehicle. There are 2 models of ripped bulldozers to consider. Model Alpha costs $150,000. 2 units of Model Alpha would be required to remove the material within 2 years. Operating costs for each unit would run $40,000 per year of 2,000 hours of operation. At this operational rate, the model would be operable for 3 years. At the end of the time, it would be estimated the salvage value is that for both machines. The other model has costs $240,000 each, has a life of 12,000 hours without any major overhaul, and costs that much to operate for 2,000 hours per year. To complete a job within 2 years, the estimated market value for both model beta at the end of 6 years is that.
Please correct.
I don't know. Once again, 2 units of model beta is required for this task. Since the lifetime of either model exceeds the required service period of 2 years, you estimate that after 2 years, the model unit Alpha could be sold for that much each, and the other one could be sold for that much. Assuming your MAR is 15%, how much would your company save by using the least costly option? Find the cost difference between the 2 options. Okay, so let's look at the 2 different cash flows we have. So we have 2 options here. The first option is to do the Alpha one, right? The first one. So let's highlight the information about the Alpha. So there are 2 model Alpha costs that much. 2 units are required to remove the material within 2 years. Operating costs would be $40,000 a year. I don't know if we need that amount of hours. The model would be operable for 3 years, at the end of which the salvage value is that for both machines. Model beta, so here I'll say that for Alpha, this is also an Alpha thing, which is that 2 years the salvage value is $45,000. Model beta costs that much, that lifetime, that much to operate. I assume that is yearly. And to complete the job within 2 years, the estimated market value for both at the end of 6 years is that. I don't know why we need that though. Let's see. Once again, 2 units of the model beta is required for this task. Since the lifetime of either model exceeds the required service period of 2 years, you estimate that after 2 years, the 2 ones have this much. MAR is 15%. Okay.
Are we using a single beta or 2 betas? The wording is ambiguous on it. It never says that we use 2 units, but it refers to them as 2.
Each? Seems like it.
Seems like 2.
You can like it might also be 3 or 4. You know, it doesn't mean only one, only like 2. You know.
No, it says 2 units of model beta is required for this task.
Yeah. Oh, once again, 2 units of model beta is required for this task. Yeah, there you go.
Since it said once again, 2 units, I think it's true.
It's confusing. Okay, so let's see here. I'm gonna do the. Someone's got their mic on. And so. Let's see. Okay, so first we're gonna deal with model alpha. So we need $150,000, but 2 of them, so $300,000 to start with. That's our payment here, $300,000. Then it's going to be $40,000 a year, but only for 2 years, right? We're working for 2 years here, so 1, 2. It's going to be a $40,000 payment, $40,000 payment, right? And I don't think we need to account for that at all right now. The number of hours. That's everything. Salvage value for both machines. So it's $50,000, not each. $50,000 for both. So I should have highlighted that too. $50,000 for both machines. So that means we're going to get $50,000 at year 2. $50,000. Oh no, sorry. The model would be operable for. Oh yeah, this is what I did wrong. The model would be operable for 3 years. Which salvage value is that? But we need the salvage value for at the end of 2 years, which was $45,000.
I just saw one thing.
So.
Yeah. Question? Yeah. Is it? No, I'm just saying. Like, is it? Because even though it says for both machines, is it?
Yeah. Shouldn't it be
for both? Yeah. Like, is it for both, or is it both machines cost this much?
Okay,
you see what I'm saying?
I guess because of the wording here, it says the unit alpha could be sold for $45,000 each. So now it's each. So I guess it must be also each up here, but it's $90,000 here.
Okay.
Operating cost for each unit is what it says. So the 40,000 is for a single unit, but we're gonna be multiplying this by 2 later.
You're right. Yeah. So I'll just multiply by 2. So we have $80,000 here, $80,000 here, $90,000, $300,000. Yeah, everything's just multiplied by 2. But yeah. Okay, now we have it. So let's find the present worth, I guess. Present worth of this. And then find the present. Well, I'll write the cash flow diagram for the other one as well. And then just compare the two.
What about the 50,000 thing? Where does that come in?
Which 50,000 thing?
The salvage value?
We have the salvage value here. This is giving you the salvage value at year 3, but we don't really care about the salvage value at year 3. We care about the salvage value at year 2.
Oh, year 2. Okay.
Which is what this is right here. We also know the salvage value at year 6 is 60,000. I don't know how that's possible. The estimated market value for both beta at the end of 6 years is 60,000. It doesn't really matter. We don't need that number, but it's just weird.
But if the salvage value is 45,000 per at year 3, then why is it 90K at year 2?
It's 45,000 each. Each. Sorry, it's 50,000 each. The wording is poor here. So it's $50,000 each at year 3. But we don't care about year 3. We only care about year 2, which is $45,000 each. So it's $90,000 salvage value.
Well, that 50K we just ignore.
Yeah, we only care about year 2 here.
Why would you keep it for extra years?
I don't know. That's a good question. I don't know. 480,000 for this first one. Then we have 2 more payments. So it was 22,500 to operate. So 22,500 times 2 is 45,000. So that's in total. So 45,000 for both. How much would your company save? Yeah, probably means present worth. Okay, and then the salvage value that we get is $125,000 each. So that's going to be $250,000. Quite a bit. Yeah, quite a bit. Okay, so let's find the present worth of both these things. So the present worth, I'll do it up here. So the present worth of this one is negative 300,000 minus, and I guess I'll just do 80,000 P given A. What's the percent? 15%. Oh, my camera's probably in the way, isn't it? 15%. 2 plus 90,000 P given F 15% 2. So that's some number. And then the present worth here is going to be negative 480,000 minus 45,000. P given A 15% 2 plus 250,000. P given F 15% 2. So let's do this. 480, 123 minus 45.
One more thing with the second one. If was it 45,000? Like, why wasn't this also doubled?
It was doubled. It was 22,500 each. So twice that much is 45,000.
Yeah, the numbers are just similar. Sorry.
Yeah, don't worry. Okay, so I'll just have to figure out what these things are. So P given A 15% 2 is fine. So P given A 15% 2 is 1.6257.
So like, are we allowed to ignore the times because the time is the same? Like, it's 2000.
Yeah, it doesn't. I don't even think it just doesn't affect anything. The time. We're not looking for like savings per hour of operation. The answer doesn't need anything to do with the time.
So like, in this case, no matter what the time would be, it just doesn't affect anything.
It doesn't affect anything. Yeah.
Sweet.
561. So I got negative 480,000. Let's see if this is right. Eight. Did I type in a number wrong? Plus 90. P given F 15%. Oh, just like, did I just type in some number wrong? I probably just typed in some number wrong. Oh yeah, I did type in a number wrong. This is supposed to be. This is supposed to be 250. Oh yeah, I was doing it weird. 250,000 is 364. Sorry, present worth is negative 364, $131 for that one, and then present worth here is going to be, well, I shouldn't have restarted that, but negative 300,000 minus 80,000 times P given A 15% 2. P given A 15% 2 is 1.6257 plus 90,000 times P given F 15% 2. P given F 15%.
Question.
Yeah. Yes.
Why is it 300K? Is that like a 50K overall or something?
Where so for this here?
Yeah.
Well,
And also for
each model costs $150,000. There's 2 units, so it's 300.
Oh, so you have to multiply that by 2 as well. Okay.
Why they make us use 2 machines? It's just like very dumb in my opinion.
Just an added complication.
Because that's what's needed for the job.
That's what's needed for the job, exactly.
Also,
okay, but like,
what midterm are you doing?
I got it's not real life, you know. I mean, it's like they're complicating the question for no reason.
They're complicating the question to complicate the question. That's the reason for complicating the question.
That's
Adam, what midterm are you doing?
That's the most university thing I've heard.
Final exam 1. Doxel's final.
Oh, final exam, not midterm. Okay.
Final exam 1.
Midterm finding.
And yeah, that's the answer. That's the difference between the two. There you go. It's 2.
That was way easier than I thought. Like, I looked at the questions, like, oh.
Yeah, there's just a lot of numbers there that we don't have to use, but.
Now, is it worth paying an accountant to do this math for you?
Yes.
To save $2,000 is the real question.
No. You program it.
There you go.
Hey, there you go. We don't need accountants.
So that means you would have to pick option B, and would save $2,000 overall.
Yeah, you pick the one with the least cost. So no, you'd pick option A.
I told you, at the start I was gonna say we go with alpha because alpha mining sounds like cool, like you're using a alpha drill. Yeah. Anyway, was it the first over the other?
Yeah, because this cost is 362,000. The other cost is 364,000. So we want to do the least cost. So.
No, I mean, was it a ratio or was it just first minus the other?
Just the difference between the two. Delta.
Okay.
When I was calculating the PW for alpha, I got negative $362,031. I don't know if it makes a difference.
It doesn't
'cause
make a
he's gonna
difference.
give us a range.
Yeah,
So,
no, I don't
but,
think it makes a
yeah.
difference. I think it's just like maybe you use like some extra decimal in the p given a. Or
No,
something
I just
like
used the table.
Yeah,
know.
the table is rounded down more.
So maybe some different rounding or something. I don't know.
Yeah, and also on the tables for Toxin and for Gurvitz have like different. They have different like the table has like different values, like slightly differently rounded. So like it might mess up your answer, especially when you're working with like 90K, 100K, a million. It messes up your numbers often.
Yeah. Okay, let's keep moving. So question 5 here is. Let me see this for a second.
Well, I have an engineer. Okay, that's kind of nice. Very nice.
This was one of the practice problems that I couldn't do when we were doing it for the mutually exclusive because the solution didn't make any sense to me. So let's see if we can make sense of it together here. So it's a very similar question. Your engineering company is considering the possibility of providing new facilities for the department, which could result in higher productivity for engineers. For an office presently occupied by 5 engineers, what minimum individual increase in effectiveness must result to warrant the assignment of only 3 engineers to run an office if the following information applies? So, office size is that. The average salary of an engineer is that. The cost of the building is that per square meter. We have this how big it is, so we have the cost. The estimated life of the building is 25 years. The estimated salvage value is 10% the initial cost. Annual everything is 6% the annual cost. Operating cost is that much per year. Interest rate is 10%. And yeah, assume nothing, whatever. Doesn't matter. So we're looking for what is the warrant of assignment of 3 engineers. No, sorry. What individual increase of effectiveness? Increase in effectiveness. So that's going to be, yeah. So again, it's just like a wording here that's very strange. So we're looking for some C. That's dollars per engineer. Dollars per engineer. Yeah.
Math.
That each one's going to give us. And I think we can do kind of something similar to before. What'd you say?
So can't you do the average salary times C or something equals? Well, let's just do a cash flow. I didn't do a diagram or something for this.
Yeah. Let's do a diagram for it. So, well, you have this kind of thing. So we have a payment at the start. Let's figure out how much that payment is. Well, the payment is going to be 4 times 8 times 1,000, right? Because it's $1,000 per square meter, 4 times 8 square meters. So 4 times 8 times 1,000, right? Just 32,000.
And then you have 6% of that every month as an expense.
Exactly. Yeah. So 6% of that is 0.06 times 32,000 is
something 600.
1,920.
Oh, okay.
1,920. Dot. Because it's going to go to 25 years, so I'll say this is 24. 1,000.
The interest rate is 10%, so we can just write it down to get it out of the way.
Sure. 1,920. Yeah, so we have just that the MAR is 10%.
And then we set the building to what? We set the building for 3,200.
Sorry, someone asked a question there. What was it?
No, I think we have to.
Joshua asked a question, I think.
No, I was saying, what does the MAR have to do with it? Because with the IRR, with the internal rate thingy, we compare it to the MAR, but it's not always. It's 50. Is it 15% if not stated? Right.
What's 15%?
The MAR, or is it? Yeah, is it? Or am I confusing the terminology right there?
The MAR is the interest rate. The MAR is so you don't assume the interest. They'll definitely give you the interest rate, unless the point of the question is to find the interest rate.
It's just a different wording for the same concept in the end.
Yeah, I don't really know what the difference between interest rate and MAR is, but yeah.
No, because like earlier when we did IRR, were we comparing it to MAR, or was it something else?
Yeah, we were comparing it to the MAR there. IRR is the internal rate of return, though. That's between projects. This is just one project.
And the 15% of MAR was what, given?
We don't have 15%. There's no 15%. 10% maybe, you mean?
In the previous question, it was given as 15%.
Okay.
Oh, in the previous question, it was given as 15%. Yeah, okay.
For some reason, I thought it was like standard, but okay.
No. Yeah. It's given the question.
And we also have to do you started billing for 3,200.
Okay, so we just did all of the cost, and then we're gonna do all of we're gonna stretch the salvage throughout the 25 years as well.
I think we need to add the salaries to our annual costs.
Yeah, we will. We'll get there. I'm just doing one step at a time here. Yeah.
Engineers be like, so no salary?
Wait, isn't dollars per engineer called tuition?
Like,
yeah.
I don't know about you, but that's what it sounds like.
Yeah, so it sounds like.
Yeah.
I like that.
Wait, Adam, I think you have to remove a zero because it's 10%.
You're right. Yeah. Okay, so the building's last 25 years. This is the 25th year over there. Then what did I not account for? The salary of the engineers. That's the only thing I didn't account for, right? So operating costs is. What'd you say?
The office size and the salary.
Office size I did account for, $32,000 to buy it. But salary I did not. So I have this. Well, I guess I'll just add on a certain amount, which is $80,000. So I guess I may as well just put an 8 in front of all these.
It's times 3.
Oop, yes, times 3.
It's 3 engineers.
Yeah. So I'll just so 80,000 times 3 plus 1,920 is 241,920 every year.
I would just find in the. Sorry, go ahead.
Taxes.
We're finding what? Sorry.
The value you erased, right? 1920.
Yeah.
What was it for?
Taxes.
That was just annual taxes, insurance, and maintenance is 6% of the initial cost. So 6%
Okay, so
of the
you
initial
didn't add the $50 to it yet, like the operating cost.
Oh yeah, I did not have that yet. Thank you. So I have to add to that value 50 times
square meters. So
4 times 8.
Multiplied with the 4 times 8.
Yeah. So that means it's going to be 243,520.
But is that the meter thing, the $50 per square meter? Isn't that just one cost and stretched throughout the 25 years?
No, what? It's $50. It's $50 per square meter. So I multiply that by 4 times 8, and then
that's the initial cost of the building.
And then that's per year. Okay.
Oh
so
wait.
It's kind of a rate to the rate then. Kinda.
Yeah, it's just another yearly cost.
Okay.
Right? Yeah. Okay. So now we want to say what cost per engineer makes this equivalent to what? It used to have minimum individually increased the assignment of only 3 engineers to an office. But see, the thing is like, so it's already occupied by 5 engineers.
Do you remember the first question we did?
Yeah.
This is similar to that, and that we want to say the minimum.
I think that for this question, you do not need that information. The $80,000, just there to throw you off.
The $80,000.
Yeah, I think it's
yeah. Okay. What I did for this question was like, you have to find the annual equivalent amount of having the office, and then you have to find out how much these 3 engineers have to do to make in order to make it just viable.
In order to make it what?
Viable, like
viable. Yeah.
Yeah. Okay. So you have to find like how much would it be to have this office in those 25 years? So the annual equivalent cost, and then just basically divide it by 3.
Or is that they just do?
Oh, and that's how much each engineer.
Yeah, that's how much the extra money they have to make.
Oh, I see. Okay, that's how much. Okay. Yeah. So take this. Yeah. Okay, I see. Take this
because
amount.
we already know that.
Find the annual equivalent cost and increase in productivity per year, per engineer per year is what it really is. We're looking for per engineer per year. Right. So yeah. Okay. Find the annual equivalent cost of all this. So that's not too hard. Essentially, it's already done for us. So we just have to find annual equivalent cost Well, we already have negative $243,520, right? That's annually we pay that much. And then we also have $32,000 present given final. No, sorry. A given P at 10% for 25 years. Right? And then we're going to subtract off this 30, no, sorry, not, this is a subtraction as well. This is an addition.
Wait, but for the question, you do not need to take into account the salary.
You don't need to take into account salary?
No, you only have to take into account how much you have to pay for the office annually, and then divide it by 3, and that's how much extra money they have to make. It's not about the salary; it's about how much they have to pay for the office.
But isn't their salary part of the cost?
No, but it's asking you how much extra they have to make. Their productivity is not how much you're paying them. It's
how much extra
they have to make.
Okay.
But,
I see.
Okay, sure.
The business owner, as a business owner.
Yeah.
Isn't their salary part of your cost as a business owner?
I think what he's saying is that their salary isn't a part of the viableness of the new building.
You could solve it with salary though, and then just subtract their salary out of the C.
Yeah, but I guess he's just saying that adding the salary is just unnecessary values.
Yeah. So I'll take the salary out of this. Yeah.
Why though? I don't understand that. Like, isn't their salary part of the cost?
But I guess the idea is that the question's asking for, like,
it's operating the new building.
Just paying for the building. Forget about the engineers. Just paying for the building, right? What is the amount of money per year that each engineer has to make? They have to make.
Yeah.
In productivity, they have to make this much.
So you can basically assume that they are making / are worth $80,000. That's what they're getting paid. So that's like.
Yes, yeah.
So
like they're making that much money, and they're worth that much money.
Okay, I see. They just wanted to match their productivity to match the building. Their salary is something else that they don't consider right now.
Yeah, they don't consider right now. They just need to see the productivity of the engineers. Yeah. So yeah, then we just do this amount that I wrote right here. Just subtract off the salary of the. In fact, I'll just write this. A given F. I'll finish this. A given F. 10%. 25. Oops. 25. And then I'm going to subtract, or actually add back, really, the 80,000 times 3, because I want to add back the salary of the engineers. Salary of engineers, right? So this will be our annual equivalent cost. That, I'm going to divide that by 3. So hopefully if I do this, I'm going to get, let's see, are we going to get the right thing?
What is the right thing?
It'll just be negative of what I have. Yeah, that's fine. That's okay. That should be fine.
But that's not even a full answer because you still haven't found like the things,
some reason the salvage value, that doesn't make sense. Okay, let me just type. Let me type this in, and I'll see what we have. So 243,520 plus 80,000 times 3, so that's corrected, minus 32,000. A given P, 10%, 25. 10%, 25. So A given P, 10%, 25 is 0.1102. Plus 3,200. A given F, 10%, 25. A given F, 10%, 25, 0.0102. That's it. So I get $7,013. $7,013.76. That's a cost. So I gotta say negative. That's the cost for each, for the whole thing. So then, the 3 engineers yearly have to account for this, right? So divided by 3. So they each have to account for $2,337. per engineer year, if that makes sense. For engineer year, which is not.
Isn't that just 1 year? So isn't just engineer good enough?
Yeah, I guess so.
Engineer. Yeah. It's just for 1
But
year.
it's also one engineer, so we still write it though, right? We're saying per one engineer. This is how much it is. But yeah, that's the idea.
Yeah. Okay.
Yeah. So it's just these questions are just very weirdly worded, and I think just not explained exactly how we're supposed to do it and what we're supposed to take into account. So yeah, they're strange, but there we go. That's how you do this one. Okay.
Sorry. In your cash flow diagram, for the annuity, you have what were the values that went in there? So there was the salary of the engineers times 3, and then there was 6% of the original cost, and then what was the other?
And then it was this operating cost is $50 per square meter per year, right? So there's 4 times 8 square meters. Multiply that by 50, and that's $1,600.
Okay. Per year. Oh, okay. So there's like an initial cost for that, and then there was the annual cost for. Okay. Thank you.
No problem. So yeah, that's right.
Didn't the question ask for an increase?
Yeah, so this is an increase. It's essentially what it's saying is that each engineer has to account for an additional $2,337. They have to increase their productivity by $2,337 a year. Right, so they have to account for this negative amount. That's what it is. They have to account for this negative amount. So we just call it a positive amount. That's what they have to account for.
Okay.
Right. It's weird. I agree. I don't know.
On the right side, that's 5 questions, and that's almost like an hour. So it's like 5 questions per hour. We're making good time.
We're doing okay. Yeah, exactly.
Yeah, the exam is 3 hours, right? So if you did 5 questions per hour,
yeah,
you should finish the exam. Okay.
Okay. You want to determine whether to keep.
Adam,
yeah.
Have you looked at Gurvit's questions? Are they any better, or are they just the same weirdly worded ones?
Gurvitz's aren't as weirdly worded as Topsoy's.
So maybe we can do some of those as well after our break. Maybe we could maybe good to move on to those.
Okay, thanks.
But yeah, we'll see. Let's go this one anyway. So you want to determine whether to keep your construction equipment excavator, which will last for 8 years. You are using double declining balance, 200% for book depreciation purposes, and this is the 4th year of ownership. The item costs $150,000 new. What was the depreciation value in year 3? So how much did it depreciate in year 3? Well, okay, so we have to use the double declining method for this. And so that is going to be for the depreciation in year n is the d value times the principal times 1 minus the d value to the n minus 1. So we're looking for d3. That d is going to be 2 over, so this d here is for double depreciation is 2 over the total number of years that the thing will last for, which is 8 years. So 2 over 8, which is 2 over 8, which is 1 over 4. So it's 1 over 4 times the principal, which was 150,000, times 1 minus 1 over 4 to the n minus 1, the n we care about, so 3 minus 1. And this we can all just plug
in. About the declining rate, I don't know if this is because, again, it's a weirdly worded question or not, but it says you want to determine whether to keep your equipment, which will last for 8 years.
Yeah.
And then it says that when you bought it, it was 150,000, and you bought it 4 years ago. So does that mean the total time is 4 plus 8, which is 12, or is it 8 years?
Which will last for 8 years. I'm pretty sure.
It's just 4 years gone.
I'm pretty sure this is supposed to be the word total here. Yeah, it was 8. He bought it 4 years ago. I understand, but it is a little bit of a weirdly worded thing here.
Yeah. Just 3, not at the time, not 3 years from now. In year 3, and n equals 3.
Yeah, but that would affect this value, this 8 here. This what we're asking. It would affect this 8 here, so that's why it's.
Oh, if it was like 2 over 4, 2 over 8, or 12. Sorry. Can you just explain this one again? The dn the whole DP thing because like it's a part of something else, but I can't remember what's this for.
Yeah,
Like,
well, so
it's just
so the asset will depreciate every year, right? So how much? There's different methods to calculate how much it depreciates. One method is the double declining balance method, which is saying that the depreciation in year n is equal to this, right? And it's this d value. In general, d is the multiplier over the capital N, which is the total number. The multiplier you get because it's double declining, so that means the multiplier is 2. If it was single declining, it'd be multiplier was 1, and whatever, any other multiple there. Right?
Okay.
And then N is the total number of years, which is 8 years. The total number of years that the assets can be used for.
So the type of decline is just the multiplier, and the formula can be used for like any type of thing. Because I see
any kind of declining balance.
So then, when you use D3, it's not the multiplier, but the year.
Yeah, capital D3 is saying the depreciation in year 3. The book depreciation. The book depreciation.
And there's like a B3 which shows how much money you have left in year 3, or something like that.
Yeah, there's book value 3, right? Book value 3, B3.
Okay.
Book value.
So this is book value 3 for a double decline. Sorry, go ahead.
I was just always wondering, like, I thought in the real world depreciate this like nicer. Like, I thought depreciation works whenever people are willing to pay for it. So like, I thought it's like kind of random in some sense. I didn't know because it's actually like this nice in the real world.
Depreciation in the real world uses CCA.
Yeah, use CCA. So yeah,
there'll be questions on that.
Yeah.
I have a question. So because it says double declining balance, for a single declining balance, it would just be 1/8. The lowercase
yeah,
d.
the multiplier would be 1. Exactly, the multiplier would be 1. Yeah, that's right. That's the only difference there. And yeah, that's the answer. $21,000 and $94.
So that's what's left of the 150, right?
That's what's left.
From the 150.
No.
Depreciated.
No. This is how much the value went down in year 3.
Oh, so it's how much it's lost. So it's not this is remaining.
Just in year 3. Yeah, it lost 21,000. Okay. We don't know how much it has remaining.
Would it just be to minus it from the original?
But also the depreciation in year 1 and the depreciation in year 2. We'd have to find D1 and D2 as well. Add those together.
This is not a cumulative thing. It's a singular. It lost this amount in 3 years and not over the 3 years.
Yeah, it lost this amount in year 3. Just in year 3.
Oh, okay.
Cool. Right, just in year 3. Yeah. Okay, guys. Well, it's 6:45, so let's take a break until 7, and then we will come back and maybe do some other questions somewhere else. I don't know. We'll see. We'll decide. But if anybody has any questions, put it in the discussion chat, and we can take a look.
Yeah, we should definitely do the challenger from this question. I feel like it's a good one. Question. It's the question 10 to 13 one.
10 to 13 one?
Yeah. Because
what is that?
I know the challenger question is gonna come with the.
Oh, it's the replacement. Yeah. Okay, that's
with the cost analysis thing. And the marginal analysis thing as well.
Okay, we will do that. Yeah, we'll do that. Okay, let's take a break until 7. So I'll put AFK on the screen here, not 8. I'll say.
Yeah, I gotta say, Toxoy's questions are way more like. He's trying to trick us more than what.
Are we also gonna take a break at 8?
We are. Yeah, we are gonna take a break.
Okay. Thank God.
Gervitz's questions are super straightforward. At least in my opinion, they're super straightforward compared to what we're doing right now.
But Tosco, he always gives like a higher range of numbers for the answers. So he gives plus or minus 5%. He gives like a mod of 5% per error.
All right, that's pretty good.
Like if you get like if you screw it up like somewhere and then along the if you choose a year, an extra year or one less year, you're still within the range of the right answer. That's what I mean.
Yeah, it makes sense.
Just a quick question. Aren't these questions just a homework question? He slapped into file and he called like final exam.
So how is everyone feeling for today's tomorrow's exam? You guys, what was your favorite class this semester? Did you guys have a favorite class? Which one?
Calculus, man. It's actually gonna carry my GPA.
Calculus? Like why calculus? Is it just because it was like easier, or what was it? Because it was like the same, pretty similar like that?
It's pretty good, and it's gonna carry my GPA.
But do you like the class itself? Like, do you like derivatives and like things like Taylor series, or do you just like it that it's GPA part?
Second note, where's Adam? But yeah, it was pretty good on a whole.
Yeah, actually, I like that. I had
Adam. Where is thy master? Well, thy teacher.
Adam.
Sage, yeah. My sole reasons for doing relatively okay in school and other people. Yeah.
Yeah, what am I gonna do next semester without Adam?
I don't know. Anybody else realize that? Well, for BME and I think computer and ELE, the times when you do math is switched. So I think ELE and computer does math in the second semester of second year. BME does the math in the first semester of second year. I'm just like, why?
Adam, you heard you are the savior.
I didn't hear.
One off. Yeah. Like, yeah.
Adam was the savior of a young student. By the way, did you get the leadership award that like everyone nominated you for?
I didn't hear anything about it, so probably not.
In spirit and in truth, it was there, right?
Yeah.
I don't think actually felt better. I think he was rigged.
Well, thank you. Yes, I don't know.
Was it student of the year for first year students or just throughout the? Oh, okay.
Yeah.
All right.
I just got the
welcome
link.
back, everyone.
Yeah, I just got. Oh yeah, that's something Adam says. Now I think about it. But it was like I just did it because I think I got a link. Like someone was like, "Yo, fill this link out for Adam," and I was like, "Oh, okay." So I just like nominated Adam. That's all.
Are you gonna?
Okay, guys.
Are you gonna start with
Let's get back into it. Yeah. Well, I was thinking maybe there's this one other one which is like the question 10 through 13 of this of Toxoy's thing, which has a whole bunch of things to it. Let me just see this quickly. It's the last.
Like a chapter 11 question.
It's what? Sorry.
Chapter 11.
I think it is. Yeah, let's see. It's replace your old stamping machine. Yeah, it looks like a replacement decision one. So it's this. So maybe let's do this, and then after this we can do some Gerbitz questions or whatever. We'll see after. So yeah. So this is the question 10 through. This is that prompt at the start is what is for question 10 through 13. So yeah.
Sorry, not to interrupt, but I was looking at Gerbitz questions, and they're a lot more clear. Ask clearly what they actually want.
Yeah, I've heard people say that for sure. So we will probably do some after. It's just that, if half the people are doing Toxoy, then maybe it's also good that we do some confusing ones.
I understand. I was just saying because I was just confused because I haven't seen Toxoy's questions. So they were just like, what is he asking for? So that's why I was just confused.
Yeah, exactly. Yeah.
These are Toxoy questions, so.
These are Toxoy questions. Yeah, but we'll do some Gerbitz ones after. If people send it. I saw actually someone send me in the chat one, so we will do that after this one. Okay.
Wait, isn't this where marginal analysis comes in somewhere?
With
I don't know if it's in this.
Yeah, with the replacement decisions. Yeah. Okay, so you want to replace your old stamping machine with a special purpose turnkey stamping machine. However, you can still use your old machine if you spend some money to repair it. This old stamping machine can be used for another 5 years. Moreover, you can sell it now to someone in the industry for $7,000. If this stamping machine is kept, it will require an immediate $2,000 repair to restore it to operable condition. Note that the overhaul will neither extend the service life originally estimated nor increase the value of the inspection machine. Inspection machine? Stamping machine. I don't know. Okay. The operating costs are estimated at $1,500 during the first year and expected to increase by $1,500 thereafter. Moreover, the estimated market values are expected to decline by that. A new stamping machine costs $10,000 and will have an operating cost of $2,000 in the first year, increasing by $800 per year thereafter. The expected salvage value is $6,000 after 1 year and will decline 10% each year. The company requires a rate of return of 10%. Okay. So what is the optimum annual equivalent cost for the Defender? So essentially, we're looking for A, E, C, D star. That's what that's.
So the economic service life or whatever?
Yeah, so D star is the economic service life. So we're looking, what's the annual equivalent cost across the service life, the economic service life? So if we look at the information about the machine here, let's draw a little, let's highlight the information first. So the old stamping machine can be used for another 5 years. So we can either keep it for 1, 2, 3, 4, or 5 more years, right? One of those years will have the smallest annual equivalent cost, right? And that will be that is the economic service life. That amount of time that has the smallest annual equivalent cost is the economic service life. So it's either 1, 2, 3, or 4, or 5. So you can sell it now to someone in the industry for $7,000. It needs a $2,000 repair. What'd you say?
So like the opportunity cost.
That's the opportunity cost, yeah. So we'll get to that when we do the cash flow diagram. And note that the overhaul will neither extend whatever. The operating costs are $1,500 during the first year and increase by that much thereafter. The estimated market values are declining by 1,000. We don't even care about the new machine just yet. We're just looking for the optimum annual equivalent cost for the Defender. So we have to check year by year. Let's say, what if we kept it for 1 more year? In fact, I won't do it down there. I'll do it over here. So what if we kept it for 1 more year, right? What is the annual equivalent cost? Annual equivalent cost for keeping it for 1 more year, right? So that's going to be, well, we have...
Wait, don't we have to take into account the year, like right now?
Yeah, like we're keeping it for 1 year. We're keeping it for the Defender for 1 year.
No, I'm saying, don't you have to count the option that you just like selling it today?
Oh, well, that would have no equivalent cost. That would be 0. The annual equivalent cost there would be 0. Or would it be 0? No, it would be
7,000.
But
then it'd be 7,000 because you're selling it for 7,000.
Selling it for 7. That's not a cost though. You'd be getting. Yeah, you're not getting it for. There's no time going by there, so there's no annual equivalent cost. I think you're just getting. That's just like getting $7,000.
So you just ignore option, like you just ignore today.
Yeah, I think so. I don't remember ever not.
Sorry, what was the overhaul though? What's the overhaul extension part though? Even though I don't think you're using it just yet, but what does it mean? Overhaul will need to extend the service life.
Oh, the overhaul? Overhaul will either this line here. This is just saying that. So it has to. You have to do a $2,000 repair on the machine to let it keep working for 5 years. But doing this overhaul, this repair, it won't extend the service life. Yeah, it won't extend the service life, and it also won't increase the value of the machine. It just makes it work for 5 more years. So let's say we're keeping it for 1 year. Actually, I don't need that huge thing, so do it like this. If it's 0, year 1, there's a few costs. We have an opportunity cost, which is the market value of the machine at year 0, which is $7,000. Right? We call that a cost because it's as if you have $7,000 in your hand right now. You could sell it for $7,000, but you're choosing not to. You're choosing to keep using it, so you're losing $7,000. And you need a $2,000 repair, so that's a total of $9,000 charge at the start. The operating costs are $1,500 in the first year, $1,500, and increased by that amount. That's everything. And we're gonna get a salvage value, right? Of, well, it was $7,000. Estimated market values declined by $1,000 per year, so that's $6,000. So the annual equivalent cost of keeping it for 1 year. Annual equivalent cost of keeping it for 1 year is gonna be, so since it's just 1 year, well, let's just do it in general. How you really do it in general? You do 9,000. 9,000 A given P. What was the percent? 10%. 10%. 1. That's a cost. Well, it's a cost. So the negatives are always confusing, but I'll just do it. Negative 9,000. Negative 1,500. A given F 10% 1. Plus 6,000. A given F 10% 1. This value is 1. These are both 1, so you can kind of forget about them. And so this will just be negative 9,000 times A given P 10% 1, which I have to just find.
Be quick though afterwards. Where did the extra negative 2,000 come from?
That's $2,000 repair. $7,000 cost and $2,000 repair immediately.
Yeah.
So.
Yeah, my mistake. Yeah. Okay.
Don't worry. 9,000.
1,500 was just.
Isn't the 6,000 P of F? Why is it A of F?
I'm finding annual equivalent worth. Annual equivalent cost. I mean, annual equivalent cost. So I need the annual
Oh yeah. Okay,
Right?
my bad.
Don't worry. I guess actually, sorry, this 1500 is already an annual worth, so it doesn't matter. That I would just leave it as that. Actually, it really doesn't matter. But yeah, that's already an annual equivalent one. And yeah, again, it doesn't matter because a given f 10% one is 1. So yeah, a given p 10% 1 is 1.1. Yeah.
Doesn't it say it increased by 1500 per year after that? So we have a g value.
That's true, but in the first year that doesn't come into effect.
Yeah, the first year. Okay.
Yeah, first year doesn't come into effect. Yes, we will do that for the next years though. 6,000. So I got negative 5,400. Let's just check if that matches what he did here. Yes, defender.
So it's probably right.
Yeah. So it's a annual equivalent cost. So I know I'm gonna mess with the negative signs here, but we're talking about annual equivalent cost. So it's gonna be a cost of 5,400. This results in
I have a question.
Yeah.
So, okay, what I'm a bit confused about is like I understand that at year 0, why does I understand the 2,000 points downwards? So why does the 7,000 point downwards? When I understand that 7,000 point the same way as the 6,000 because you're gaining money.
No, you're not gaining money. It's saying that you could sell it right now for $7,000, but you don't. You don't sell it for $7,000.
It's basically the same thing as like losing 7,000.
Yeah, because you can think of it like you have $7,000 in your hand. You could have the $7,000, but you're choosing not to. You're choosing not to sell the machine for $7,000. So it's as if you're making a payment of $7,000.
So, and then it's 9,000 because you're combining with the 2,000.
There's also a $2,000 repair to do. Yeah.
Okay. So okay, that makes sense. But I thought it would like go the opposite way. So it was like 7,000 and then down 2,000 and then that makes sense.
Yeah. So just to give people, like, if you're confused about why I'm doing this, so the direction we're going for is what's the annual equivalent cost for the defender? We're going to do this for years 1, 2, 3, 4, 5. Well, we don't actually have to do all of them, and you'll see why. But one of these years, there's a unique minimum. That's the course convention we have, is unique minimum. One of these years is going to be the minimum that this value will have, right? And so that's the year we're trying to find. That amount is what this is asking for. The optimum annual equivalent cost is the actual value of the equivalent cost at that minimum. So we're trying to look for it. So this first one was 5,400. Now I'm going to do it for n equals 2. N equals 2. So let's draw the cash flow diagram. So we still have a $9,000 payment at the start, right? $9,000 payment. Then we have 2 years. At the end of the 2 years, I get, so we got, it's $7,000 value. 2 years later, that's going to be a $5,000 value. And that's because the values are expected to decline. The market value is expected to decline by 1,000 a year, right? So then I also have a operation and management fee. So that's going to be $1,500 during the first year and expected to increase by $1,500 every year after. So $1,500. And then it's like you have $2,500. Okay, so 1,000. Well, it's gonna be $3,000 here. And just to make it done generally, so like we can apply this, we don't have to like think about it too much for the next cases. Is we just say AEC of 2 is gonna be okay. Well, annual equivalent cost of 2, so it's gonna be $9,000 payment. A given P 10% 2, and you know what? I'll even highlight these things. 2. Then it's going to be minus 1,500. That's already an annual cost, so we can just say minus 1,500, right? Minus 1,500 A given G 10%, and then again this is 2. So the reason I'm doing it like not really differently than before, just writing it out kind of fully, is because you see that I'm highlighting the 2's. That's kind of like an N, and so when we go to year 3, you can just replace all the 2's with 3's, and then it'll work for that as well.
Wait, so you're just breaking up the annual payments into like the small, into like the standard ones and like the ones that stack, so you don't have to
exactly
like,
yeah. So this amount is just these 2 payments. This is accounting for this payment here, if that makes sense.
So wait, so I'm just confused a bit. The first minus 1,500 is for the first year, but then everything after is just the gradient. Like, isn't it also
No. This
increasing?
1,500 is saying we're gonna pay $1,500 every year, and
Oh, so
additionally
it's not
we have a gradient of 1,500.
okay. Also, where the 6,000 once it's now 5,000 because it's like it's the same value but it's decreasing.
Yeah, because you
it's
see the market value started at 7,000 at year 0, and it's expected to decline by $1,000 per year. So we're 2 years later, so it'll be 5,000.
It's weird because like it's the same thing where the $7,000 was at the beginning. It's the same salvage value that we're putting into the equation. But okay.
Wait, how is it the same salvage value? The 7?
Sorry, because like in the beginning, I'm sorry if I'm confusing anyone. In the beginning, it's like you can sell it right now for $7,000, so you consider that you're losing it. But isn't that the same value that's decreasing by 1,000 each year?
Do you mean opportunity cost?
Yeah, isn't it technically the same thing as a
No. So the opportunity cost. No. Because the opportunity cost is saying at year 0, how much could you have? You could have 7,000 at year 0. The amount of time that you keep that thing for doesn't change the fact that at year 0 you could have had $7,000. I could keep it for 5 years after, and I'd still have the ability to get 7,000.
It's the same as before when we have like the do nothing option. It's sort of similar. It's like, well, you could just sell it right now.
Okay, but just to be clear then, where does the 6,000, which now decreases to 5,000, come from? That's a salvage value.
It's the salvage value, yeah. It's the salvage value, right?
It's which is like, yeah.
Which is the market value, which is the market value of the product.
All right.
So
it's because like in essence it's kind of this, because I was thinking like in essence the salvage value is kind of the same thing as the opportunity cost, which is selling it. I'm like it's the same thing, but okay.
It's essentially the same thing. It's just that the opportunity cost is at year 0 and the salvage value is at any other year.
Isn't within, and it's actually a percent bonus, but okay, yeah, I get it now. Thank you.
Yeah.
Sorry about that.
Don't worry. So here we go. This is that. So the reason I did it like this is just like the 2s you can just replace with 3 for the next one. So yeah. So here we're gonna have a given p 10% 2. See, it's a 10% and I want 2. So, okay, -9, I'll just write it all over again. So -9,000 times a given p 10% 2. A given p 10% 2 is 0.5762 minus 1,500 times a given g 10% 2. A given g 10% 2 is 0.4762 plus 5,000 times a given f 10% 2. A given f 10% 2 is 0.4762. Okay, and I got 5,000, a payment of $5,019. So it's a cost of that. So I realize that's negative of what I said up here, of course, but we're talking about a cost, so hopefully that's not confusing. Which is fine. Okay, so that's that. So what we notice is that it's gone down, right? It's gone down. So we don't know. This is definitely not the minimum. So it could be this. Let's check the next one. And if that one is even lower, then we'd have to check the next one. So let's check AEC3. And so the nice part now is that we don't really have to think about what we're doing.
Yeah, because they say that like they're not gonna give us situations where like it goes up and down, like when it starts.
No, it's always gonna have a unique minimum.
No, you know what the trick is? The trick is you just find where the derivative equals 0.
Yeah, that's true. That's true.
If only, man. If only.
Well, you probably could, but it'd be. I don't think that'd be easier.
I don't know how you would derive. Well, they are equations, right?
They're equations. These are. You can get a function.
But the function is never answered. Like it's.
That's the bonus question that you see on the exam. It's like, hey, to derive this.
Yeah.
No,
do this
bonus question.
Using multivariable
optimization.
Sorry,
I missed that one. You guys.
Bonus question on the math exam is like, hey, the midterm you took the exam you took 2 days ago. Nah, bro, you're gonna find the derivative of the function. There you go.
Yeah.
You're welcome.
Isn't it 4,000? Shouldn't it be 4,000 A of F?
Yeah, you're right. You're right.
Yeah.
This is 4,000 here.
Yeah.
But wait, why is it? Is it a flat value that's decreasing at the same time at a 10% A given F? Like I thought that it was decreasing $1,000 because of the A given F, and not it decreasing regardless, and then it has a percentage.
No, it's
kind of
decreasing
weird.
by $1,000 a year. It's decreasing by $1,000 a year. This A given
Regardless.
F, this
Yeah.
A given F is making it an annual payment. Like we're saying A
Oh,
given F,
yeah. Okay,
annual given this final amount that we get. Right?
The more you use the thing, the less its value.
Yeah.
Okay.
It's more used.
A given, whoa, that's a G, sorry. That's a weird G. 0.9 9366 plus 5, so it's 4,000.
Yeah, it's 4,000.
A given F 10% 3. A given F 10% 3 is 0.3021. So I got syntax error.
I got 5315.
Yeah.
But
So
someone double check.
I got that too. So 5315, a cost of that. Now, what we notice is that that's higher than the last year's cost. And since we're assuming a unique minimum, that's the minimum. 5119. So the answer for part A is that AEC for the Defender in its economic service life is 5,019, and the actual economic service life of the Defender is 2 years.
So that means after the second year you would sell it, but you would use it for the second year?
You'd use it at least for the first 2 years. You could use it for a third year. That depends on the challenger, though. That depends on the challenger.
I'll give you a quick hint. I'm pretty sure that AEC 1 is almost always not going to be your like economic service life.
It could be, but probably not.
So wait, what happened here was that it was
I was
higher.
Why didn't we go further? Because what if like AEC4 is lower than ACE2?
That's what I was saying. It's just like we have the course just has unique minimum. We know it's one minimum, so there won't be like the graph isn't going to go like this. The graph is just going to go like that. So we assume the moment we see a minimum point, this is a minimum because the 2 points next to it are higher.
Okay, got it.
That's
Thank
the
you.
Yeah, so it's basically always going to be down, 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 and then up, 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 up. It's always going to be that pattern.
Exactly.
And then the last kind of down, it's like the lowest one, that's you just pick that year.
That's the year. Okay, any questions about this? I think Joshua was asking something.
No, I was saying originally, the reason I kind of spaced out for a bit, but the reason we chose year 2, I don't remember what the first one was at. The first one was higher, then it dropped to the second, and then it increased again. So we see a pattern that it's gonna start increasing after that.
That's right. So that means that this is the annual equivalent cost of the economic service life.
The AEC is literally the combination of if you were to graph the salvage value and you were to graph the cost.
Yeah.
You get two lines like sloping in opposite directions, and then you just find the minimum.
You could tell on the exam technically. If you want to flex the muscles.
You could graph it and
try
it out.
No. Don't try that.
Yeah, don't try it. I don't recommend, but
no, it's like if you just flex on Gervit or the other professor, you just be like, yo, look at this graph I just drew for you.
Yeah. And you can't
admire
it, so. Okay, so look here. What is the challenger's annual equivalent cost for holding it for 5 years? So this isn't asking what is the optimum one. It's saying we're holding it for 5 years. What's the annual equivalent cost of holding it for 5 years for the challenger? So I'll just take a picture of the challenge, just the paragraph that has information about the challenger, and then move that down here. We're just looking for the annual equivalent cost where n equals 5. We're keeping it for 5 years. Holding it for 5 years.
I wonder if there's a software that does this for you, because I don't think on the job.
Most definitely, yes, probably.
It's not hard; it's just very tedious.
Yeah.
You know?
You should just spend time finding that software.
Yeah.
Wait, was that just part of the question?
I heard you say
this is just part of the Joshua. This is just part of the question. We only need the part with the new challenger.
No, no. Is this like part B?
This is part B.
Isn't this the part of the question? Okay.
And if a software doesn't exist, you'll make an Excel spreadsheet that does it for you.
Yeah, that's
So you guys are gonna get on that, or you guys are just talking? Cause like I'm all about that
I'm a
action.
software engineer here. Let's get the software going.
Okay, so
if we have time,
you try it. Yeah. Okay.
The Excel spreadsheet doesn't sound too bad. It just needs a lot of time to like format everything.
Yeah, that does.
Wait, can I help you out with the question?
Well, I mean, I think I got it, but yeah, sure. Tell me what you think.
Just for practice. I know you got it.
Okay.
Okay, so you, at year 0, you do down 10K.
Well, I didn't even read it yet. So new stamping machine will cost 10,000 and have an operating cost of Okay, so down 10K is correct.
And then the next thing you do down 2K.
Yep. So we lose $2,000 here. Yep.
And then 2,800, like down.
Yeah.
And then you keep going 2,000, and then 30, 600, and then
1, 2, 3, 4, 5. Yeah. So one more 5,200. Okay, there we go.
And the salvage value is 6,000 times 0.9 to the power of 5.
Yeah, that's right. That's right. So we're gonna lose 10% 5 times. So that's gonna be 6,000. So the salvage value here at the end is gonna be 6,000 times 0.9 to the power of 5.
Which is 3,542 and 94 cents.
3,542 and 94 cents. That's correct. Okay, and this is the cash flow. So we just find the annual equivalent worth of this. So that's not too hard. So the annual equivalent cost, I guess, is going to be, so a $10,000 payment at the start. We're going to do A given P, 10% 5. Now we're going to do a $2,000 payment each year. And then an $800 gradient. So it's going to be P given G, 10% 5. And then finally, we're just going to get 3542.94 at the end. So I'm going to do A given F, 10% 5. And this will be it.
I know the formula for the gradient. Since I equals the depreciation percentage, it's just n over 1 plus I.
You're saying for P given G?
Yeah, for P given G.
The thing is you're thinking G like it's going up by a percentage, a geometric gradient, but that's not the case here. It's a linear gradient. So it's just
increasing by 10% each year, isn't? Oh.
No. The salvage value is 10% each year. The operating cost is $800 a year.
I got messed up.
Increases by $800. Don't worry, yeah. So
shouldn't that be A given G?
Yeah, you're right. You're right. It is A given G.
A given G, because, or yeah, you can do A given G. Yeah. If you think of the geometric gradient, yeah, you can do A given G.
You were thinking about A, yeah. So negative 10,000 times A given P 10% 5. A given P 10% 5 is 0.2638. Minus 2,000 minus 800 times A given G 10% 5. A given G 10% 5 is 1.8101.
Imagine if you actually had to calculate all these values like by hand, like use the big formula every time.
That's why you use the factor table if you have to do it by hand, yeah. A given F 10% 5 is A given F 10% 5 is 0.1638.
I believe there's apps all over the internet for this kind of stuff.
Yeah, I agree.
Hey, but we are in the exam. We can't be using apps over the internet, you know?
I'm just saying, like in real life, you want you doing this.
It's hard because the conditions can vary a lot. Like not every cash flow is exactly the same. So.
Yeah, I have a question though with the.
An app will do exactly as you put input. You have the input of it. Doesn't matter.
Yeah, I have a question though with the whole. You know how in the previous part of the question where we had or I think it was a different question altogether with the 1,500 and then minus 1,500 and then minus 1,500 at a gradient.
Yeah, that was part A here.
Yeah, what's the fundamental difference between that? Why it has a minus 1,500 here on its lonesome, and then minus 1500 at A given G at 2? Is it just because the first one is just for the first year? I don't get it.
What was the question? Like the difference between these two terms here?
Yeah.
Well, so
because in the next question you have the same concept where it's increasing at a specific amount, but it's not minus 800 and then minus 800 at a continuous thing.
Look at here. What's the baseline payment we pay always?
Oh, the 2,000.
2,000 is the baseline payment we pay always. $800 is how much it goes up by each year.
Okay.
So similarly here, right? What's the baseline payment? It was $1,500, and it also goes up by $1,500 each year.
Okay.
Right? But those won't always be the same.
What was your answer?
I just typed something in wrong here. Yeah, I got not the.
I got 5,505.67, but I could be wrong.
Yeah, I got something similar. I think I just 638 plus.
I've also noticed that for all the annual equivalence costs, like you put positive, I keep getting negative in all of them, but I don't know if that.
I know, it's a cost. It's a cost, right?
Yeah, I know it's cost, so you put it as positive, but I don't know.
Oh, the difference is 1, 2, 3. Wait, what? 5. Huh? Wait, that doesn't make sense. 5.
When Adam says, "Huh,"
I don't think it's. Isn't the salvage value? It's 0.9 to the 4. It's 6,000 after 1 year.
Oh yeah. $6,000 here. Then it goes down 1, 2, 3, 4 times. So that's a 4. Right there.
Wait, is this the 600 or 6? Where's the 600?
6,000.
6,000. Okay.
0.9 to the power of 4. Yeah, and now I get negative 5. So 5441.8. Yeah, so someone said just now I'm doing something weird with the negative signs. I am doing something weird with the negative signs. This is a cost, so this should really be positive, negative. It's just that it's kind of weird to write it like that because it's weird to say that this is a positive amount even though it's a cost. But remember, we're measuring cost. So what I do is I just write it might not be the best way, but I write it like this when I'm doing this, but then I just take the negative of the answer. Because this is technically negative annual equivalent cost. And then to get the annual equivalent cost, I have that. It's the positive of it. It doesn't really matter. The magnitude is what matters. As long as you know what direction it's supposed to be in, then...
For A given G, how does it work? In the sense that, how is this... it's rows around it, the cash flow diagrams, how do you know the A is going to give this going to be the right one? You know what I mean?
Yeah, well, what the idea is that this A given G is saying, okay, at year 0, there's...
But you get my question in some sense?
What'd you say, what?
Did you get my question?
Why is this giving you the right answer? Why, what are the rules around using this?
I know that A given G we're doing is going to move the money how we want it to move. Because for example, when you do P given A, it moves to 1 year before the first cash payment.
Yeah.
So it moves it to the right place and not
this moves it 2 years before the first increase. So the first increase is at year 2. So 2 years before that is right here, and that's where we want the cash flow to be.
And if it's an A, just spreads it off from there to the last one.
If it was what?
Given G, then it just spreads it out from 2 years.
Yeah. If it's A given G like what we're doing right now, it just spreads it out over 5 years. It's essentially P given G and then A given P together. That's what it's doing.
As long as the front lands the 2 years before the first one, it's good.
Yeah.
For the first one.
Yeah. What we're doing now is what it's supposed to be. Exactly the situation how we have now. Yeah.
Thank you.
Yeah, no
so can you just do a recap of these questions real quick?
The part B here?
Yeah, there's a part B.
Yeah, so part B, well, we're just going to make the cash flow diagram for everything here. Sorry, I don't know what that arrow's doing there. Why was that arrow there? I don't know. So we're just going to make the cash flow diagram for all the information. So the cost, the yearly cost, the initial cost, and the yearly cost, and then the salvage value, all just based on what's written. And then we just need to find the annual equivalent cost of all this. So I do A given everything for here.
Okay, so... yeah, I get that. What was I don't remember who was saying it, but something about the 2 years ahead or something like that.
Yeah, everyone was saying it. Well, it essentially it's just like how does A given G work? Really, the question is actually how does P given G work? So if you were asked P given G 800, that would find you the present worth at year 2, but why at year 2? At year 1, at year 0. But why at year 0? Because the first gradient is at year 2, and that's how P given G works. It brings it 2 years before the first gradient payment.
So, I mean, in this particular question, because it starts at year 2.
Well, no, always. I mean, if the cash flow looked like, this, and it was like nothing for these years, and then here it was 500, and here it was 600, and here it was 700. Well, sorry, I'm starting in year 2 again, but I meant to start like let's say here we're starting at some later year, so this is 0, 1, 2, 3, 4, 5, 6, 7. Then if I did P given G on this gradient right here, it would bring me to year 4.
3.
Because it'd bring me 2 years before the first gradient payment. The first gradient payment is in year 6. 2 years before that is 4.
What was it? Well, yeah,
the first payment is at year 5, but that's not the point. The first gradient payment is at year 6.
Okay.
Right?
Okay, makes sense.
And for the exact same reason, P given A brings me to year 4 as well, because that's the rule there is it brings you 1 year before. This one brings you 2 years before.
Is that just a conceptual thing? Like, do we have to know that really? Like,
well, you have to know that to be able to use this stuff, to be able to use it properly.
P given A? It's like, sorry, say the P given A one again, because I didn't get that one.
The P given A? Well, P given A is the annuity, the $500. The $500 each time, that's going to bring it back to year 4 if you do P given A. Because that's your year 0, right? It brings it back to year 0. But
so it brings it 4 steps ahead, since this would be at the year 0. Okay.
Right, it brings it here. And then if you want to actually get year 0, you'd have to do P given F of this amount here.
Okay.
If you get the present value.
Something like that.
Okay, so then that's the answer for this one. So that works for part B. Anybody stop me if there's any questions? So question 12, what is the
No, I was just like, honestly, it still doesn't really click with the P given A and the A given G, because like it's still at we're still working with year 5, but I don't get the concept.
Well, not year 5, 5 years. Not year 5 is right here, but that's the only thing right there, right? We're working with 5 years. And there's 4 gradient payments.
Yeah, okay, in this question.
We'll do a lot more examples, and we'll see where it comes up to. So, yeah. Question 12 is, what is the cost of the defender when you replace it with the challenger? What is the cost of the defender when you replace it with the challenger?
Like how much? I guess it means how much does the defender cost at that time when you replace it with a challenger? So like at year 2,
like
how
what's
much?
The market? Like what's the market value?
That's what makes sense to me. Yeah, something like that.
Is that the whole? I don't know if it's the wording, but anytime I see a question like that, I wonder if that's when they're asking like to compare it with like the marginal thing, with like increasing it 1 year, or when is it equal to the same cost as the challenger?
Well, I think I know what it means. So what it means is, so we have to find at what year do you have to replace the defender with the challenger, and then let's say you replace it at year 3. So then you have to find how much you sell it at year 3 when you're doing the replacement. It's like 4,000 or whatever.
Okay, so we got to figure out when do we replace the defender with the challenger. That's the idea first, is to find when do we replace the defender with the challenger.
So then we have to do.
To figure that out, we compare. First, what we do is we compare. So let me go to my notes here. Oh, I lost my notes. Where did they go? Here. So scroll to it.
So we just have to find when AEC of the challenger is smaller than AEC of the defender, and then just
almost. So compute the cost of running the defender. So sorry, compare AEC D star and AEC C star. So AEC D star is this. Then we need to find AEC C star. So the annual equivalent cost of the challenger in its economic service life. Right? So we're looking for AEC AEC C star for the challenger. We already found it for the defender. Now we got to find it for the challenger. So what we can do is essentially, while we do kind of like this right here, right? So here, let me make this more general. I'll just say this was, that value right there was 6,000 times 0.9 to the power 4. So, and this was AEC 5. So to just like, to generalize it a little bit, I'll put 5s.
Wait, was it power 5, Adam?
And what, sorry?
Was it into the power 5?
No, it's power 4, because you see, in this year, it was a value of $1,600, and it declined 1, 2, 3, 4 times.
Oh, yeah.
Right. So there you go. So to generalize there, it's a little easier for us to find all the AEC 1s and 2s and 3s. So let's start finding it. AEC 1 would be
so we have to do what we did for part A, but for the challenger.
Exactly. We're looking for where is the I keep saying academic. Where is the annual equivalent cost, the minimum?
Okay.
So AEC 1 is going to be negative. So it's just everywhere you see a 5, you put a 1. And that's the only difference. So I'll start with 3. Let me find the calculator. There we go. So 10% 1. Okay. So
wait, you have to compute AEC of 4 just in case it's.
Yeah, we do also need to do 4. I just didn't have space on the screen to write it yet, so that's why.
Okay.
I will do 4. We know 5 already right there. That's 5. So we don't need to do 5. But okay. So
well,
negative 10. Yeah.
Defender 2 a couple more years in case.
What is it?
You might have to compute the AEC of the Defender 2.
You may have. Yeah, you might have to. Yeah, we don't know quite yet, but we'll see. We'll see what's gonna happen. So AEC 1 is just going to be negative 10,000 A given P 10% 1 times A given P 10% 1, which is 1.1, minus 2,000, minus 800 A given G 10% 5, A given G 10% 5, oops, sorry, 10% 1 is what I meant to say, and that's 0, which makes sense because you wouldn't have it there, so that's just not there. Times 0. So don't let me say 5. It's supposed to be 1. The green's 1 because we're doing AC 1. Plus 6,000 times 0.9 to the power of 1 minus 1, which is 0. Times A given F 10% 5. A given F 10% 1 is what I meant to say, is just times 1. So negative $7,000 is the 0th. Oh, that is the first one? Wait, that doesn't make sense. Let me check the table that's here. Whoops. Where am I? Oh no, that works. Never mind. It does work. I don't know why I thought that didn't work. It was fine. Okay, so that was for 1. Now for 2, we just replace all the numbers with that are 2. Sorry, all the 5s with 2s, and then we do that. So A given P 10% 5. And by 5 I mean 2, because I can't say the right number ever. A given P 10% 2 is, A given P 10% 2 is 0.5762 minus 2,000 minus 800 A given G 10% 2. A given G 10% 2 is 0.4762. Plus 6,000 to the power times 0.9 to the power 1 times A given F 10% 2. A given F 10% 2 is 0.4762. So I got 5,000.
Yeah, I'm sorry. Are we doing this all off screen and just showing the values?
Yeah. I'm just, but you see, because I just made the general equation here for n, essentially, for n.
Where?
N.
Oh, okay.
Right? Oh, I realized probably my camera's covering a few of the numbers, so there you go. For n.
No, I forget that we could use it back for this part as well.
Yeah, right. So this is for the challenger. So yeah, I just made the n equation, and I'm just plugging.
So the challenger had the same exact values for everything?
What do you mean?
With the, because you're using the one from, oh, maybe I'm mixing it up. I thought this was for the defender. Yeah.
No, this is for the challenger. The defender's up here. This is the defender.
Okay.
This is for the challenger.
Okay.
So I'm just plugging in now. 3 for this. So
okay, and just find economic.
Yeah.
Okay.
Yeah. And then so for 3, also yeah. So just a quick note, like this went down. So we're going down, so we'll see what the next one is, and we'll judge from there. So for 3, I need negative 10,000. A given P, 10% 3. A given P, 10% 3 is, A given P, 10% 3 is 0.4021 minus 2,000 times minus 800 times A given G, 10% 3. A given G, 10% 3 is 0.9366 plus 600 times 0.9 to the power of 2 times A given F 10% 3. A given F 10% 3 is 0.3021. So I got 5,302. So still going down. We got to check 4. But it looks like, you see, we go up for 5, right? We go up for 5. So the economic service life is either going to be 3 or 4. We know that much at least now, but let's figure it out. AUC 4 is going to be here, and AUC 5 we already know from right here, which is 5,441.8. So for 4, we just plug in 4 to this equation here. So negative 10,000, A given P 10% 4 is what did I do? Percent 4. A given P 10% 4, 0.3155 minus 2,000 minus 800. A given G 10% 4. A given G 10% 4 is 1.3812. 600 times 0.9 to the power 3 times 0 times A given F 10% 4. A given F 10% 4. There, 0.2155.
You still finding the shelf economic shelf life because
service life, but yeah.
Service life.
Yeah.
So are we still finding more values if we already found in year 3 that it was the lowest?
Well, we didn't know if it was the lowest. We didn't know. We didn't know if year 4 was going to be lower.
Okay.
We didn't know if year 4 was going to be even lower, right? Right. It could have been higher. We don't know. But now we know that the lowest amount is in year 3 because that's 5,302, which is the lowest of all these things. So what that tells us that AEC C star is 5,302 and C star is 3. Okay. So now to decide when do we replace the defender with the challenger. All we got to look at is these things. AEC. So all we need is this. Yeah.
Just to interrupt. Could you post like the questions for Toski, whatever his name is?
So yeah, his problems.
Yeah, like this question. Yeah, problems that you're doing right now.
Sure.
Thanks.
I put it in discussions, I guess. It's in discussions now. There you go. Just put it.
Thank you.
No problem. So, okay. For here, AEC D star, I'm just going to write out all the information we know so far. This is the replacement decision we're going to make here. Replacement decision is what we're going to make. So AEC D star, we decided was 5019 and D star was 2. 5019 and that D star was 2. And I'll also write AECN, which is useful to have, which was negative 9,000. Sorry, AEC, I should be clear. AEC DN. Right? So D for the defender. This is the defender we're talking about. So I'll just write it just so we have it. So it's going to be negative 9,000 A given P 10% N. Given P 10% N. Minus 1,500 A given G 10% N. That's good. And then just here it's going to be, well, not 4,000 because it's going down by 5,000 each year. So it's going to be 7,000 minus 1,000 n. Right? It's, yeah, 7,000 minus 1,000 n. 7,000 minus 1,000 n. And we're going to multiply that by a given f 10% n. Okay, and that's for the defender, and now just for the AEC C star, we said was 5302. C star, I mean, was 3. And AEC challenger in terms of n is this equation I wrote right here. Right, so I'll just copy and paste it. This equation right here. Oh, it's almost 8 o'clock, I just realized. Okay, so now that we know these two general forms of the projects.
Wait, didn't we already find AEC for the defender for year 3, and we know it's higher than?
Yeah, I'm gonna get to that. I know. I'm gonna get to. I just have to explain. Yeah, that's the decision that we're gonna check. Yeah, for sure.
What are we checking?
Yeah, so that's I'm about to explain that. So the first check to do is this is the first step in replacement decision is figure out these two sets of things. Then step 2 is to figure out compare AEC D star with AEC C star. So which one's bigger? So AEC C star is 5,302, D star is 5,109. So C star is bigger, right? So if the opposite was true, the challenger should be chosen right away, right? If this was true, the challenger would be chosen right away. Because what we're saying is that the lowest annual cost you could get from the defender is still bigger than the lowest annual cost you could get from the challenger, so you may as well right away switch to the challenger. But this isn't true for our case. It's the challenger is bigger. So then we have a new question we have to ask. We have to say, well, we're going to keep AEC, we're going to keep the defender, I mean, for at least 2 years, right? For at least 2 years. But then you have to ask, well, what's the cost of running it for 1 extra year? What's the annual equivalent cost of running it for 1 extra year? And we're going to compare it to that. So we're going to compare that to AEC C star. So AEC D star plus 1, AEC D star plus 1, essentially, is saying let's keep it for 1 extra year. What is that annual equivalent cost? Now the thing is that that's the annual equivalent cost of just running it for that 3rd year. Just running it for that 3rd year. You have to consider 3 things. The salvage value, which is the opportunity cost at year 3, or at D star.
Oh, wait.
Yeah?
So will we get any questions where the annual equivalent cost of the challenger becomes cheaper before the economic service life of the defender, or no? Wait, you want to rephrase that?
No, I know what you mean. I'm not really sure. I don't know how you deal with that either.
What was this question?
What?
Yeah. Like, will we get any types of questions where the challenger becomes cheaper than the defender before the defender it reaches its cheapest point?
I don't think so.
No, that's a very interesting question.
I don't know how to deal with that.
Because in that case,
it's usually just challenger being more, and then you do the marginal analysis and increment the defender by 1 each time and see where it stands. I mean, I think it could be the reverse as well, but I don't think you would need to do that because, like, if the challenger is already better, then you wouldn't need to do the marginal analysis because you just do the challenger.
Exactly.
Because in that case, don't you just need to like check every single situation and then say, okay, year 1, which is cheaper?
What's gonna happen? What's gonna happen is that's gonna be true, and then you just choose the challenger. That's what's gonna happen. You just choose the challenger right away. So that's what's gonna happen. Is that you're gonna have the defender annual equivalent cost is gonna be higher. So you would choose the other one. Yeah. So annual equivalent cost of D star plus 1. To do that, you consider three things. You consider the salvage value. So you only consider it for keeping it for that third year. The annual equivalent cost of keeping it for that third year. Not all 3 years, not year 1, year 2, year 3. Or sorry, I guess D star, what was D star? D star was 2. Yeah, so just for the third year. You only consider that. So that's going to be the opportunity cost you're losing. Opportunity cost. So, well, it's a cost.
I just had a quick question.
Yeah, sure.
Is this question still from chapter 6?
This is chapter... no, this is chapter 11.
Okay.
Yeah. So, minus 11... Sorry, minus the salvage value that you're getting from it, plus the operation and management cost. Right? So this is opportunity cost at D star. At D star. Oh my god. D star. This is the salvage value at D star plus 1. And this is the operation and management cost of the year D star plus 1. Not times D star plus 1, I should be clear. Of D star plus 1. This is the thing. So what's the opportunity cost of D star? Well, what did we say about the challenger? Or the defender, the defender. So the defender goes down in value by $1,000 every year. It starts at 7,000. So at year 3, or sorry, D star was what? D star was 2. So it's going to be 7,000, 6,000, 5,000. Opportunity cost is 5,000. Salvage value is 4,000. But it's 4,000. Sorry, I'm realizing I have to bring this all to annual equivalent. So it's going to be 5,000 A given P 10% 1. So you're just spreading it over 1 year. Minus 4,000. That's okay. That's already there. Okay, I'll write it, I guess. A given F 10% 1. Plus the operation and management cost for that 4th year, which is going to be... I know it's 8 o'clock, so I'm finishing up in like 1 minute. This part of the question. And then the operation management cost is 1,500 during the first year, increased by 1,500 every year after. So it's 1,500 in the first year, then it's 3,000 in year 2. Year 3, it's 4,500, and in year 4, it's 6,000. So we care in year 3. Actually, we don't care about year 4. So we care about year 3. So it's going to be...
I have a question about the $5,000. So that's from the $7,000 you would have gotten from selling it, and then subtract 2,000, which is the overhaul cost for the repair, right?
No, careful. That's the $7,000 we could have. That's the market value at the start was 7,000, but then the value declines by $1,000 every year.
Oh, okay.
And we've gone 2 years, so it's $2,000 less.
Okay, all right. Thank you.
No problem. So 4,500. Yeah. And
no, I was just saying, I didn't really. Sorry, go ahead. No, I was just saying with this last part, I didn't really get it with the D plus 1. This is the marginal analysis, right?
This is marginal analysis, yeah.
So, and how we do that is I can't say a part of it. Opportunity cost of D minus the salvage value plus 1. I don't get that bit. Is it just the?
This is the opportunity cost
at
your D star.
At that year, okay.
Salvage value at your D star plus 1. And operation and management cost at your D star plus 1. Yeah.
So for the salvage value at D star plus 1, it's the economic shelf service life was year 2, so that's why we're using the 4,000, and then we're just doing the A given F of that.
Yeah. Because we want to spread this over. Yeah.
No, I was just saying, why would we still use the $4,000 of that was for year 2 if we're doing one year extra? That's the part I'm still getting.
4,000 for year 3. Year 3.
Oh, yeah, okay.
That's the value at year 3.
That's where my confusion is.
Yeah.
Okay.
There you go. So
sorry to interrupt, but the opportunity cost, like a little formula that you wrote, is that in general? And can you use that for?
That's in general. Yeah, that's in general.
Okay.
Yeah.
All right. Thank you.
That's in general. So this is the marginal analysis, and then you might have to do this a few times because you see the answer I got from here was $6,000. So what that tells me is that if I keep it for an extra year, that's going to cost me $6,000 for that extra year, just for the extra year, not for 3 years in total. For that extra year, it's going to cost me $6,000. We then compare that to the annual equivalent cost of the Challenger, which is $5,000, which is less, right? Which tells me, since that's less, that means that it would be better for me to replace it with the Challenger at year 2. So the first year, that means replace it with the Challenger at year 2. That's the answer, I hope. Replace it with the Challenger. AEC D-Star.
It says year 3.
Yeah, I see that too. No, because AEC D-Star is that. So, same thing that I did, 6,000 D-Star plus 1. So this is AEC. This is the annual equivalent cost for the third year, D-Star. Let's look at my formulas here.
I think it's like I think it's saying like at the end of year 2, so it's like it's not the second year. It's at the end of the second year, which is the beginning of year 3.
Yeah.
Because at year 2 we're still using the Defender.
Yeah. So if compute the cost for running the Defender for the nth year after its economic service life. If this cost is greater than AEC, then replace the Defender. Then the Defender should be replaced n-1 years after its economic service life. So we're looking at the the first year, so 0 years after its economic service life. Yeah, its economic service life is 2. No, but then that would mean you replace it at 2.
We are replacing it at 2.
We're replacing it at the end of 2. It's
no,
not the same.
It is exactly at 2. We only do end of year compounding, which means the end of year 2 is when the last payment for that economic service life is, which is fine. So
he said year 2, so year 2 is included in the thing. J0 is 1, 2.
Okay, guys, it's 8 o'clock now, so I know some people have to go. So we're not gonna move on to another question. So if people have to go, then go. We will take a break for a little bit. But yeah, let's finish talking about this question for just a few more minutes, and then we'll take a break. So yeah.
Yeah. So what Adam drew there, where he circled the first year and the second year, that is how many years that we're gonna do the first project, and then on the second year, we switch to the next one. But that doesn't mean that the first payment for the next projects on the second year, the first payment actually comes at the end of
the second year.
Well, no, that's the third year. It's the third circle.
At the end of the third year. But the answer in the thing says in year 3 change the Defender. Oh yeah, in year 3.
Yeah. So end of year 2 would be year 3.
Okay, that makes sense. No, we didn't do anything wrong. It's just the word in there. Yeah.
It's just so basically for the everything really with the first 2 years we're using the Defender, which is year 0 to year 1, then year 1 to year 2, and then afterward, which is year 2 to year 3, we're gonna use the Challenger, right?
Yeah, that's right.
And you're saying something about not paying the Challenger cost until the end of year 2.
Yeah, you don't pay it. Happen at the end of the year, so you don't actually pay anything when you switch to the Challenger until the end of. We annualized it. That's it. I mean, you do, but like we annualized it. That's what we're looking at.
Yeah.
Okay. I know that this doesn't make any sense, but imagine if you just continually swap, because you say you don't pay until the end. You just like
no.
cycle through.
We annualize it, but you do pay during the year.
I know.
Another way to do this, this is calculating marginal analysis. If you go up to where we found annual equivalents for the Defender for year 3, you'll also notice that should be larger than the annual equivalents of our Challenger. That's 5315. Ours was 5309, I believe, right? 5302. Yeah. So
So why is it costing us $6,000 though?
The
Like what I
6,000
don't.
the 6,000 isn't saying for the first 3 years. It's saying in the third year. What's the annual equivalent cost? There's a difference.
Oh,
right?
so
We
what's
already
so
when you
what's
find
the
AEC for the defender for 3 years, that's
yeah?
already included. You've taken that cost into account.
So it's not that you're paying that amount. That it's just that for the defender at that year would have been equivalent to that cost.
It would have been
right?
equivalent to $6,000.
Yeah.
So it's better to go with the cheaper one, right? It's better to go with AEC, the Challenger, because that's cheaper in that year.
At year 3, which is the reason it confuses me because when you scroll up to the AEC off year of the defender at year 3, it's not 6,000. It's
Yeah.
what is it?
Because that's not it's 5,315. Because that's not saying what's the cost in year 3. That's saying what's the annual cost over the first 3 years of use.
Oh yeah. Oh, okay.
I'll give you a trick. If you take AEC 2 and then you annualize 6,000 for would be I guess 3 years, you should get 5,315.
Same.
Add that
I'm
together.
pretty sure.
Can you scroll?
So
Yeah. Sorry. Go ahead. No, go ahead.
I was just saying, so the conclusion is that because now it's 600, so that means now is so in the third year you should replace the defender with the challenger by third year.
Yeah, in the third year. I think that just
In the
means
third year?
at year 2, pretty much. That means at year 2.
Okay.
Right? Just call it that. At year 2 is when you should do it.
You know what's weird? When I was saying at the end of year 2, I literally meant end of year 2 going into year 3, but you could also interpret it as end of year 2. It's just never mind. It's just so trippy.
Yeah.
Counting's hard, guys. Counting
is hard. We
Counting,
really gotta master between 0 and 3. We gotta start there.
Yeah.
And then we'll go. Yeah.
You're like, so what's the biggest problem as engineers? You're like, counting the
Counting
difference
the first
between
3 numbers.
Yeah, it's just it really gets us, man.
Yeah. Exactly.
Integrals, derivatives, easy, but oh gosh, 1 to 3, when you can, oh my gosh, no.
Dude, you can't even count all the numbers between 0 and 1. It's
That is so
actually
weird.
impossible.
Yeah, it's just like
literally can't do it.
I'm gonna count them for you. Ready?
How are we
0,
supposed to do
1.
anything if we can't even count to 1?
yeah, it's so hard.
How is it? Yeah.
Okay, guys,
So,
let's take a
yeah.
break. Let's take a 15-minute break, and then I will be back. So yeah, we'll start. Let's just
We
take
need a moral booster though, Adam. We're losing people. We're losing way too many people.
That's okay. Well, the people had to
We're
leave just
losing
now
people?
for. Well, not really. Still
For
50
food.
people here.
We had 2 servers full. Now I feel like we're at.
It's okay.
Oh, still have
It's
2.
okay. I'm not that good at economics, so I'm not surprised that.
No, it's mean like it's the shared effort of like trying to solve the
Yeah,
questions. Like
yeah.
this one is not passive learning, man. This one you really have to like
This you gotta figure
take
out.
part in the question.
Okay, guys, back at 8:30.
Actually,
Okay, so. I'll be
Yeah,
back.
see you. Yo, Shali, were you
Okay, guys, I am back.
Yay.
I'm back.
There we go.
Hello. Adam, do you have two screens? You don't have to have a guy to have two monitors.
I do have two monitors.
Is that like is it true that that's a prerequisite to be a computer engineer? You have to have two screen monitors. I mean,
they have that. If you go to the if you go to the computer engineer website, it's right there. Minimum
so
of two screens.
You have one, or is that just an instant reject?
Yeah, you just don't get in. You just don't get in. It's not possible. Part of the application, you got to send a picture of your two screens.
So what happens if you try to send a picture of a friend's two screens to finesse?
You'll be caught. They can just tell if you're a one screen kind of guy or a two screen kind of guy.
So, yeah, I could sense that I was a two screen type of a guy.
Yeah, exactly.
And then what's your opinion on 4 screens?
4 screens? That's cool.
Yeah.
If you want to have 4 screens, I'd like a third one because for streaming it would be good to have a third one. But
hey, what do you have on your 2 screens? Like, did you have the
did you guys? Have you guys started anything? I was just jamming and I realized you guys were
we
back
didn't
on.
start anything yet.
No, nothing.
Good.
But like, wait, did you just see Discord and what you're drawing? That's it?
Yeah, the one main screen is what I'm drawing. We see the same thing on the one screen, like what you see, and then I have on the other screen. I usually have like Google Chrome open with like things I need, like my notes or something like that.
You have to switch to Discord manually.
I don't really go to Discord that often. Yeah, I switch to Discord manually, but I don't really go that often. That's why I would need a third screen, is to put Discord, like the chat on the screen.
No,
they should have told us that a requirement for online engineering is a second monitor.
Yeah, you need a third screen for Discord and a fourth screen for like stream donations. You know, chat donations.
That's true. That's true.
Like, thank you so much for the $2 donation.
Yeah, that'd be nice.
Adam, have you ever? Adam, you should do Twitch streaming, but like with math.
With math, I don't know if there's that much of a market on Twitch for math streaming.
No, it's to escape things like that. Yeah.
If you ask number 5,
let's go.
If you ask number 5 when he started off, he would have said that people back then might have thought that who would go.
That's true.
Math.
Maybe that's a fair point.
That is fair.
You have to be the entrepreneur. You have to be the beginner, the beginning of the thing to start the math.
That's true.
Or get banned. Get banned.
Let's get back into it. Let's get back into it here. Let's get back into it here. So just a quick recap for what we did right before the break was, I summed up what we did with the AEC D star and AEC C stars, and so we know and we found the general formula for AECN. Actually, I realize I don't actually need that now, so I didn't have to write that, but whatever. So first comparison we have to make is AEC D star was less than AEC C star. So what that means is that we have to check now. If I were to keep, so just remember here quickly, D star is 2. So if I were to keep the Defender for one more year, what is the annual equivalent cost of that third year, right? Of that third year. So that's kind of what I'm trying to say here. AEC D star plus 1. Right, so it's not the same thing as AEC D like of 3 annual equivalent cost of the Defender for 3 years. It's just that third year. What is the annual equivalent cost? So you'd be doing opportunity cost. I should write this in here. So if someone said in general, yeah, it is in general, but you need to put the 10% 1 here. So I guess I percent 1 there, and that's it. That's all you actually need to put, because you see A given F 10% 1 is 1, and both those are just 1, so it doesn't matter. So technically, full general, you need to put that there. A given P I percent 1 multiplying there. And so that's just saying what's the third, just for the third year, what's the cost? That's $6,000. That's more than the Challenger, which tells me that I shouldn't be using, in that third year, I should not be using the Defender. So in that third year, I'm going to replace the Defender with the Challenger. So that's essentially what we're saying. And yeah,
what
that's
D star and C star represent again?
D star is the economic service life of the Defender. So D star is saying what amount of time should I keep the Defender that's the lowest annual equivalent cost. Does that make sense? So annual equivalent cost is like, we calculate it up here. Which one has the lowest? What amount of years should I keep it for? That'll give me the lowest annual equivalent cost. That's D star. AEC D star is that cost, that minimum cost.
Okay.
Yeah. But that's not really answering the question. So the question was asking, It's almost answering the question. What is the cost of the defender when you replace it with the challenger? Now, when you replace it with the challenger, I don't really understand what they're saying. So we know when we replace it with the challenger. What is the cost of the defender? What kind of cost? Is it the yearly cost? Is that what you're saying? In that third year, that would be 6,000.
What year did we get? 4?
No. We replace it during year 3. So at the beginning of year 3.
During year 3, how much does it cost? Then you just do 7,000 minus 3,000, so that's just 4,000. So it just costs 4,000. Because they're basically asking, when you do decide to replace it, how much will you sell it for? How much will you get for it? And basically,
is that what it's asking?
Yes, that's what it sounds.
What is the cost of the defender when you replace it with the challenger?
Yeah. Well, how much does the defender cost when you do decide to replace it with a challenger? So during year 3.
Oh, okay. So then you're saying, yeah.
So just 4,000 or whatever.
No, 5,000. It'd be 5,000 because you replace it. So it's 7,000 here. No, it'd be it's
5,000.
It's 7,000 here, and then it's 6,000 here. That's when you're replacing it. So it's $6,000 is what you do.
Wasn't it 5,000? No, but doesn't 7,000 start at year 0 or?
No, year 1. I'm pretty sure. Oh no, sorry. You're right. Well, you can sell it now. Now is year 0. So you're right. So that's gonna be. This is gonna be the 6,000. This is gonna be 5,000 here.
So you're saying it for 5,000.
If that's what that's asking for, the answer doesn't even include this. It only includes up to this AEC thing.
Year. Yeah.
So
what's that? I don't get that. Like I thought at first I thought it was the same 6,000 because I was just like, what's the cost? I was just like, well, isn't this the cost? Because the annual equivalent cost. Like I was confused about that.
I don't really know.
What I said made sense to me at least. You know what I mean? Because it sounds like when you do
how much
decide,
could you buy it for? Yeah.
Yeah, how much will someone buy it for off of you? You know, that's what makes sense to me. But you know,
maybe. Yeah.
University question I don't know for being straightforward, so it's all good.
I'm not sure. Okay, but let's look at part D then here. Under the finite planning horizons of 8 years, compute the present worth of the following option. So this isn't too bad. So what this is essentially saying is that the notation here is saying that we keep the defender for 2 years, then we use the challenger for 4 years, and then the challenger for 2 years. And what's the present worth of all this, right? So, well, all we do is, okay, well, we keep the defender for 2 years. What's the annual equivalent cost of that, right? What's the annual equivalent cost of that? Keeping the defender for 2 years. Well, that's $5,019, right? Because D star is 2 and AEC D star is 5,019. So the present worth is going to be $5,019 annually for 2 years. So P given A, 10% 2. So that's accounting for this. I'll underline it. That's accounting for this. Now we need to know for the defender, or for the challenger, for the challenger, because now we're in challenger territory. What's the annual equivalent cost when you keep it for 4 years? Well, the annual equivalent cost when you keep it for 4 years for the challenger is right here, $5,317. So that's going to be $5,317. And what we can do is we can just say, well, it's actually kept for 6 years. Just consider it like you keep it for 6 years. Oh, no, that's wrong. Never mind. Keep it for 4 years because it's a different cost when you keep it for 2. So keep it for 4 years.
Does it matter when you buy it and when you sell it? Or does it just matter that at some point you said, like, it just matters that you keep it for 4 years? Doesn't matter that...
It matters how long you keep it for. Yeah, it matters how long. And what order it's in, too.
If you decide to buy and sell it, like, later.
No, it doesn't. Yeah, it'll affect the later price. Because look what I'm about to do. So P given A, 10% 4, but then I have to do P given F, 10% 2, right? Because this is gonna bring it. This is gonna be. So what we're doing essentially is 1, 2, 3, 4, 5, 6, 7, 8. So from year 1 and year 2, this is the defender. The next 4 years, 1, 2, 3, 4, that's this one, and then the challenger, and then 2 more years is the challenger. So when the annual equivalent cost, I bring that back, so it's 1, 2, 3, 4 years. That's bringing it back to here, right? This is bringing it back to there, and I got to bring it back 2 more years to bring it to present worth.
So this is basically just a fancy question of asking for present worth.
It is, yeah. I should be a little bit more general here, and I think that's probably better. So I'm going to do AEC of the defender for 2 years. That's what I'm saying. AEC of the defender for 2 years. This is AEC of the challenger for 4 years, and I'm going to do AEC of the challenger for 2 years, because the next challenger is only kept for 2 years. Then I'm going to do P given A, 10% 2. And where will that bring me? It'll bring me right here. So I got to go 1, 2, 3, 4, 5, 6 years back. So P given F, 10% 6. And now, just again to write it out, we know all these numbers though. AEC D2 was AEC D2 was 5,019. AECC4 and AECC2. 4 was 5,317. And the other one was for 2 years, 5,571. And I just plug all this in. And that would be my present worth. Plug all this in here. So that would be 5,019 times P given A 10% 2. Someone's got their mic on. And so here we have P given A 10% 2 is 1.7355.
Wait, is it individually or is it collectively? Like, are we finding the entire thing individually, or is it a collective present worth that
collective present worth? Each of these are the individual present worths. That's an individual, that's an individual, that's an individual, right? But notice we have 3 different sections. So I did wrong colors. That goes there, that goes there.
This said like option. I was just like, is it like choosing between them? Oh, but okay, I see what it
is. This is an order. This is saying use the defender for 2 years, use the challenger for 4 years, use the challenger again for 2 years.
So another 2 years. Okay, yeah. Right.
So that's what that's saying. Okay, so then yeah.
This annotation always starts from 0, and it always starts from 0. It always follows the same pattern, right? Just go on.
It always starts at year 0, and then it always the defender is first. It says how long you keep the defender for, right?
Yeah. And then the only variation of this is if you have an infinite sign, which just means you just keep.
Then there's some other things to do. There's a formula for that, but yeah, we'll hopefully get to do that. P given A 10% 4 is P given A 10% 4 is 3.1699. P given F 10% 2 is 0.8264. Plus 5,571 times P given A 10% 2. 2? Yeah, 2. P given A 10% 2 is 1.7355 times P given F 10% 6. P given F 10% 0.6545. So I got $28,966.9. And there's no answer key for this, so don't know, but that's almost definitely right. So present worth, bring it all back, and yeah. So there we go. That's that question. So that was a whole replacement analysis question, replacement decisions question. That, quite a bit to it.
So that'll be the entirety of chapter 11.
This is a chapter 11. This is like the main bit from chapter 11. Yeah. I was thinking.
I have a question. So for the exam, will they just ask us one of these things, or if this is a multiple choice, so it's gonna kind of take long to do.
Yeah, so I wouldn't be surprised if we have one like this, question 11. Well, I mean, yeah, that would be pretty. That wouldn't be too hard though. But this.
Does Topcoat use like the multiple choice on D2L, uses the quizzes, right?
Yeah.
Because if those are randomized, it randomizes what questions you get in what order. I don't know if they can do that.
If they can do what? Oh yeah, like to have
Because
one
like how
with
would he ask
multiple
you
parts.
10, 11, 12, 13 if it's like 10 is at the start, 12 is at the bottom.
Yeah, I know what you mean. Yeah. So well, yeah, I don't know. It would be one at a time, and they'd probably give you the whole set of questions there. But it's a 3-hour exam. How many questions is it on the exam? I forget.
16.
15 plus 1.
And, yeah.
Oh.
15
Wait,
plus
it's
1.
spaced out. Wait, were you still working on the same question with the present worth for the 8-year span?
He just finished.
Yeah, we just finished it. That's the present worth right there.
Okay.
So I was thinking now we do one of the income statement sheets questions.
Yeah.
Because I'm sure that's gonna be there.
Yes, we will definitely have a question like that. Now that the last question on this midterm is the income statement sheet. So
can someone build a income statement sheet? Because I'm pretty sure the professor recommended that we have one.
Yeah.
Just like to fill in.
Yeah, both professors gave one. So the one that I have from Toxoy looks
they
like.
have?
Yeah, both professors gave it. Looks like this.
I'm surprised if they give us one of those questions where they give us one and then just like it's like one question and then it's like 3 to 4 parts to it, and basically the other 3 to 4 parts just makes you complete everything, you know?
Yeah, probably. So okay, let's start this question. I'm gonna, I've done this sheet once before, so let's see. Hopefully it goes well, but we'll probably get a little work together here. Where did the pen go? Where did I just put it?
In a place far away.
Oh, right here. It's right in front of me. I'm just blind. Okay. So yeah, this is now going to be an income statement question with the income statement sheet, and let's give it a try. So I'm going to highlight all the information as I go. Hartsfield Company is considering the purchase of a new milling machine during year 0. The machine's base price is $135,000, and it will cost another $15,000 to modify for special use. The capital allowance rate is given as 30%. The machine will be sold after 3 years for $80,000 actual dollars. Use of the machine will require an increase in net working capital. Oh, working capital is something that I don't know how to do. Okay, but let's see how it goes. At the beginning of the project year, the machine will have no effect on revenues, but it is expected to save the firm $80,000 in today's dollars per year in before-tax operating costs, mainly for labor. The marginal tax rate is 40%, and this is expected to remain unchanged during the duration of the project. However, the company expects the labor costs will increase at an annual rate of 5%, but the working capital requirement will grow at an annual rate of 8%, caused by inflation. The selling price of the milling machine is not affected by inflation. Okay. Do we even know the selling price? Yeah, we do. Those are in actual dollars, so makes sense. It's in 3 years of actual dollars. That means the same thing as saying the selling price is not affected by inflation. The general inflation rate is estimated to be 6% per year over the project period. Okay, 6% per year over the project period. The firm's market interest rate is 20%. Okay, we got a lot of things here. So what is the net income in year 3 is what we're looking for. Net income in year 3, we're looking for this box right there. Okay, that's the box we're looking for. So let's start filling things in. So it has a base price. The machine's base price is $135,000. It'll cost another $15,000 to modify. So I'm quite certain that we can just combine that into one cost, right? And then that'll just be $150. Yeah. And so I'm going to put that in investment. So I'm going to make the pen size smaller. That's why my pen size was smaller when I started the live stream today. $150,000. Let me write that nicer. $150,000 goes right there. Okay. The capital allowance rate is 30%, so I'll put 30% right there. The tax rate was 40%, so I'll put 40% right there. Okay. So definitely, I have in my notes here, I've done like row by row. I mean, what goes in each row is what I made that here in my notes. So you can take a look there if you go down to the thing. It's not like the most. It's there. It's row by row. It's everything. So it starts with revenues, expenses, operation management, all the things, and also it labels all the things that are affected by the inflation rate, right? So the inflation rate for the general inflation rate is 6% per year. Specifically for the working capital requirement, it'll grow at 8%, but that's fine. We'll deal with that in a second because I don't really know how to deal with that. so the capital allowance. So the machine will be sold after 3 years for $80,000 actual dollars. So after 3 years, yeah, after 3 years. So that's going to be here. It's going to be salvage and 3 years, 80,000 of actual $80,000, not affected by inflation. So that's I actually put 80,000 there. The use of the machine will require a net working capital of $10,000. So to my understanding, I put 10,000 right here, and then something has to fill in these values, which we'll figure out because I have to figure out what that is. So
does it say constant or actual for the capital?
Well, it's at year 0. It's at the net working. It starts at year 0. That value. So I
Yeah.
think but I don't know. After that, it says the capital working requirement will grow at an annual rate of 8%.
So just multiply by 8% every year.
Oh,
not quite.
Well,
not quite.
no.
No, because we'll see. We'll see in a second. We'll see when I do it. Let's fill in everything else we can for now. The machine will have no effect on revenues, but it is expected to save the firm $80,000 today per year. So I'm pretty sure we can just say that's a revenue of $80,000 in today's dollars. So you can kind of think of it like, so I'm going to erase this. This isn't quite right what I'm about to write. But you can say it's a revenue. So each year we have $80,000 in revenue. But we have to adjust for inflation for all these things, right? So these are in 80,000. This is $80,000 in today's dollars, so in constant dollars. So we need to convert constant dollars to actual dollars. Yeah.
I can't really see, like, because the video.
You're right. You know what? Here, how about this? Whoops.
Bottom left corner. Oh no.
There we go. That's my solution, and that will probably be better. Okay. So there we go. So here, $80,000 is our revenue, but we need to, again, like I said, we need to convert from $80,000 in constant dollars to $80,000 in actual dollars. So to convert,
Adam?
Yeah.
I'm pretty sure it's 15% for the CCA. It's the half rule something, half something.
Yeah, but the rate is 30%, but we're going to use the 50% rule against it. But the rate is 30%. And so when we calculate CCA, we'll take into account that 50% rule. But still, like the actual value of the rate is 30%. So we still write that there like that. So convert from constant dollars to actual dollars is done like this. Now I'm not exactly sure where my face ends, so put it here, I guess. So to do that, we do, so F given P, potentially we just do this at the inflation rate. So $80,000, 1, 2, 3, times 1 plus the inflation rate, which is 0.06. Sorry, for 3 years, actual dollars. Yeah, that increases at 6% to the power 1. So this is actually 84,000. Well, I shouldn't. You have to be careful when I say actually, but yeah, 84,800 actual dollars. I guess that does actually work. So actual dollars are here, and then I'm just gonna apply that twice for this one. So that's gonna be 89,880. Sorry, 888. So this is just n equals 2 in this formula. And then n equals 3 is going to be 95,281. So those are our revenues, tax-adjusted revenues.
Wait, so
yeah.
So then revenue starts at n equals 1, and then at n equals 0, and then n equals 1. You apply the first count of those at inflation.
Well, there's no revenue at n equals 0 because the year hasn't passed yet, so there's no revenue. So
it's like, how are we inflating revenue that hasn't even
we inflate the revenue in year 1. The revenue in year 1. We inflate the revenue there.
80K before you can inflate it.
Don't I have to what? Sorry.
But you already have to have it at 80K before you inflate it.
The ADK?
No, at 80.
Oh, the 80K. Oh, yeah. Well, like it's $80,000 of year $0. It's 80,000 year $0. But how much is that in year $1? It's 84,000 year $1. 84,800 year $1.
Okay, let's see. Okay.
So that's why it's converting.
Still actually have to have it.
Yeah, you have to inflate it like that. Yeah. So now we have that after 3 years, the net working capital. We'll forget about that for now because we don't need it just yet. The capital cost allowance rate, expenses. Is there no expenses? I don't see anything about expenses.
Built into the revenue, they say that's how much they save.
Oh, I see. Okay, yeah. So pretty simple actually. There's no expenses and no debt interest.
Question.
Yeah.
You calculate the actual amount of dollar, but just multiplying the 80,000 times 1.08 to the n.
That's right.
I'm getting the different value than what you have.
What do you get?
I had
1.06. 1.06. And is that a mistake that I made?
I think it's 0.8 annual.
That's for the
that's for the working capital. That's for the working capital.
Oh yeah. Well, I see.
It's 6% for everything else. Yeah. So there you go. Okay, so now the C. Sorry, go ahead.
Yeah. I'm sorry. 6% for the inflation. I see.
That's right.
Sorry, my bad.
Don't worry. So yeah, so now we're gonna calculate the CCA. We are gonna use the 50% rule because I think you just always use the 50% rule. So let's see. You don't actually always, but I think for our purposes, you just always do. So using the 50% rule to calculate the capital cost allowance, you do this. Again, all these formulas I'm just getting from my notes. So if you're wondering where I'm getting it from, hopefully, no, my face can't be covering it. Yeah, no, we still got space.
One thing though, before we continue, what was someone saying about how do you clarify not having any debt interest and expenses and O&M? Like, what was that from? It said something about it being built into the.
Yeah. So here it says the machine will have no effect on revenues, but it's expected to save. Oh wait, hold on. Net working capital. The machine will have no effect, but it's expected to save the firm that much money in operating costs, mainly before labor. So what it's saying is that by using this machine, forget about the revenues. By using this machine, we're saving $80,000 in our operating costs. So you can just think of it like we have no operating costs and we're getting a revenue of $80,000. That's the green lines I just underlined there.
So basically,
yeah.
Okay, I was just saying. Basically, it's just saying it technically it's like there's no actual revenue, but since it's you're not getting any expenses, it's helping you like avoid expenses. It's basically like a revenue.
Yeah, and then we just say no expenses. We just forget about the expenses.
Okay.
Okay. We have a question.
Yeah.
If we're not considering any costs, right? Why is there a annual rate for labor costs?
Annual rate, however, the company expects labor costs will increase at an annual. That's a good question. Labor costs will increase at an annual rate of 5%, but the working capital requirement will grow caused by inflation. Expected to be unchanged during the duration.
Does that mean the amount of money we make decreases?
That's what I'm thinking. We lose 5% of our profit every
Man,
year.
Toxoy's questions are so like, what the heck?
Intense, yeah.
It's like, but wait. Yeah.
Here he says he doesn't even give the solution. He says detailed solution in our last Zoom meeting.
Yeah, it's on the
nice one.
The PDF is there.
Nice
no,
one.
the PDF is there. The PDF is there. Yeah, he sent it and go down to the last, because that's what I was just looking for. I was like, what the? What? It's in the last section.
Oh, Zoom meeting.
I'll just send it here.
Yeah, I see.
Last Zoom meeting, the PDF. Yeah.
Do you want to
just?
Because
I was looking for it before.
So then, are we multiplying it by 0.95 each year as well? If it's an increase in cost, that'll be a decrease in revenue.
Yeah. So you do multiplied by 1 minus the inflation rate. If it is a decrease, or if it's an increase in the operating cost, it'd be a decrease in the revenue.
That's what I'm thinking.
Yeah.
Do you want to just do Groovit instead? If this is too.
Nah, but yeah.
We're doing it.
Wait, we haven't started Grivitz's yet.
No, you have to do this one because if you have Toxoy, you might get this question.
Yeah.
Yeah, we're gonna get this question.
So he does sales in constant dollars, 80,000. Labor savings, 80,000 1 plus 0.5 to the 1. So look here. He's using the 5%. He's using the 5%, and it's a gain.
The same values that we have here.
But he's gaining 5%.
So we did do it right. Wait, he's using 5%? I thought we did.
Something's not
Oh,
right
he
here.
uses the. Oh, okay.
So wait, so his revenues uses the 5% increase in over the.
We save a constant dollar value of $80,000. So even we always save $80,000 in constant dollars. So that means if the cost of labor goes up, we're saving the same amount of money, but in order to make sure it's the same amount of money, we're technically saving more dollars, but those more dollars have the same buying power as 80,000.
I see.
We're always saving 80,000 each year.
Oh, we're always
it's just
saving
adjusted
80,000
for inflation.
Oh.
But there's
that make
like
sense?
that's after the fact
But-
of like inflation
yeah.
and so on. Then
Yeah. Okay.
Okay.
But it's expected to save $80,000. So you're saying that the amount we save, yeah, is always $80,000. That exact amount, but not adjusted. The thing is saving. Why would it go up by 5% then? That's like.
it's because the inflation it's increasing, right? So the money, the total, I'm quoting with my fingers now. Total like revenue that we're getting is still increasing, as someone said, by that 5%. So we can keep that constant $80,000.
Like, do you get sort of the idea?
I think
we're
I
always
yeah.
we're always saving $80,000 no matter what. We
Yeah.
save $80,000 on labor. But if labor costs go up, we're saving even more money in labor costs, but it's actually the same buying power as 80,000.
Yeah.
It's inflation. It's weird because it's not an interest rate. I can't say like if it's not like a P given A type thing. It's like
Yeah.
that 92,600 is the same buying power in year 3 as $80,000 would be in year 0.
Just a minute. If we say that we had like, let's say a different thing, our machines save us $20, but our labor cost is $5. So the total saving is like the total revenue is 25, and let's say that cost increased by $5. Our revenue will increase by other $5, so to match up to make it like also 20. The difference between them is still 20.
Yeah.
Is that what you're saying, guys? Am I understanding it right?
Like, but with inflation in there, so like.
Yeah.
Yo.
So you just match up the increase in cost, right? You just match it up.
You match up the fact that we're always in actual dollars we're saving $80,000. We're saving 80,000. That the value that we're saving is technically lower because our labor cost is increasing. But
you mean technically higher? Because
no, because you'd save less if the annual rate went up. I mean, if the labor cost went up.
You save the same amount.
Yeah, so your revenue have to increase to save the same amount if your cost increased.
But the machine has no effect on revenues.
Yeah, like the saving. It's supposed to be more just to cover up the increasement in cost.
You will always save $80,000 in year $0.
Yeah.
You'll always save $80,000 in year $0 every year, regardless of how much your operating costs are. You save $80,000 year $0 every year.
Mm-hmm.
Which we've adjusted for inflation already. We've taken that into
that
account.
Was for 6%. I think we did 6%.
Yeah,
we did.
And we have that labeled in our.
We need to change it to 5% though, according to Toxoy's way of doing it.
So wait, what were we initially doing that 6% for again? It was
the inflation. The inflation.
It was for the 6%. Wasn't it for the inflation rate? Wait, I'm so confused. So the 5% is from what then?
We were the 6% that we were working with is converting the current the dollars to the other dollars.
Yeah. The constant dollars to the actual dollars.
Okay.
Yes.
Okay? And so now to account for the fact that we're increasing our annual rate the labor cost will increase at that rate. That means that it's always it's equivalent to $80,000 in today's dollars. So essentially, it's an interest rate of 5% that's applying to the revenues.
Is that just a weird way of like F given P or something like that, where it's like this is the future value?
Yeah, it is. It's exactly F given P.
We sort of went over this in Gervitz's class, where we did. There was an example question on multiple rates of inflation. So like different things would inflate at different rates. He said that wasn't going to be an R test, but this is sort of what's happening on this one, where you have multiple rates of inflation.
I feel like I'm sorry for the people who are here in Gervitz, and I don't know if we're doing justice by doing toxic questions right now. So,
Well,
I don't know.
Here's the thing: you're getting a more in-depth understanding from doing Toxoy stuff right now.
Yeah, I think so.
Yeah, sometimes that
more confusing questions.
Sometimes it's not necessarily good though. Sometimes like trip the heck up.
Explain everything at the end. Like we need a summary when we actually understand the question, because
Yeah. Let's see.
Would you rather have it be complicated while you're reviewing or while you're writing the exam?
That's a fair point right
Let's just get CCA out of the way, because we know how to do CCA.
I like living my life on the edge, so I write the exam, of course.
I'll write these 84. I'll write these 80 the thousands in here quickly. Squared 88,000. So this is increasing at 5%. 88,200. 92,610. 600. Yeah. Okay. Now, so that's fine. That's the revenues. They're increasing at an annual rate of 5%. That's fine. So
it's a cost though. It's an expense, increasing at 5%.
Yeah. But these should be in terms of 80,000. No, but that would be at 6% though. Not at 5%. But let me see what.
I feel like what we had in, to explain my thinking, I feel like what we had in the revenues was correct, and then we also put in the expenses. We basically have the increase at a rate of 5%, and the difference, basically the difference between the two of them is actually what the expense is. Like whatever that 5% change is the year one expense. Whatever the 5% change is in year two is the 2-year compounded expense.
But we don't know what the initial expense is. Like we don't even know what to say 5% of, right?
Toxoy uses 5%, so you have multiple inflation rates. The 6% is going to affect your capital, your what's it called? The capital, working capital, and it's going to affect when we try to find the present worth, because we're going to have to find the discounted rate.
Yeah.
But this is a multiple inflation rate question. So 5% on revenue. We don't have any expenses, so I guess it doesn't matter. We have a CCA rate.
So
we have a tax rate. So we just need to do.
Yeah, we're almost there. So let's do CCA rate. So CCA for year one with the 50% rule is the principal, which was 150,000, times D over 2, which was 0.3 over 2. So 22,500. These are all incomes, yeah. And then for the nth year, it's just going to be 150,000 times D, which was 0.3, times 1 minus 0.15 times 1 minus 0.3 to the 2 minus 2 is 0. So to the power of 0. So 38,250. And then for year 3, the only n difference is the 3 up there, so it's going to be our 1. 26,775. Okay, so now to find taxable net income. Oh, I lost my notes here. To find taxable net income, we do Taxable income is revenues minus total expenses minus CCA rate. Sorry, minus CCA minus debt interest. So we only have revenues and CCA rate. So it's going to be the revenue, which is 80. So for year one, 84,000 minus 22,500, which is going to be net taxable income, which is going to be 61,500. Next, we have 88,200 minus 38,250, which is 49,950. 92,610 minus 26,775, which is 60. Why is that such a difference there? Did I do something wrong? Let's see. 92,610 minus 22,775. 65,835 for that one. Let me check my numbers quickly. 26, 38,250, 20,000, that's fine. 61,500, 49,000, 65,000. Yeah, we're good. So now income taxes, we do, for that, we do income taxes is taxable income times income tax rate. So I'll start. 61,500 times 0.4, which is 24,000. 24,600. Next we have 49,950 times 0.4, 19,980. Next we have 65,835 times 0.4, which is 26,334. Okay, and we're looking for this net income right there. And so net income is taxable income minus income taxes. So taxable net income minus income taxes. So we just care about this. Well, I guess I'll do all of them. So net income here is going to be 61,500 minus 24,600. 36,000. 36,900. Yeah.
No, okay. Did you finish what you're doing? Okay. I have a question for. Okay, first of all, the taxable net income and the income taxes, and also, where's the whole application of the 15%? Like, okay, we did it here in the CCA, so we did we use 15% in the consecutive years,
wait,
right?
Why 15%? Where are you getting 15%?
Sorry, not 15%. We're using 50% of what we were originally given, right?
Like the 50% rule, you're saying? 50% rule?
Yeah.
All that means, just think of it like this, you just means you're using these formulas for the CCA. Don't worry about what exactly you're cutting in half. Just it means you're using these formulas for the CCA. Without the 50% rule, there's a different set of formulas, which are almost the same, but just slightly different.
Okay, so which one specifically are we using for the one in the table?
Well, CCA 1 has its own formula, and then CCA-N has its own formula.
Oh, CCA 1 just means year one?
Yeah.
Okay, and then the UN is for everything after?
Don't worry about UN. UN is the book value in year N, but we don't really care about that in this particular case. So CCA-N is for everything after that.
Okay, and then the taxable net income, what did you do there?
Taxable net income is revenue minus total revenue minus CCA.
Oh, okay. And then you just did the income taxes at 45% off.
40%, yeah.
That's 40 off the value of the net income.
Of the taxable income, income, which is here. Yeah.
Sorry. Okay, when the taxable net, is it per year? As in, we use 40%. So, like for the first one, we did 40% of 61,500, and so on.
And then for year 2, we did 40% of 49,950.
Okay. All right. Thanks.
40%. Yeah. No problem. Okay, so then the first answer is 39,501.
Hey, could you go through everything again? Cause I kind of got lost. Okay, so I know that for the revenue on top, I know it's just 80K multiplied by 1.05, 1.05, and 1.05. But the CCA part I don't get. Like, where do you get the CCA part?
CCA, I'm just using this formula for CCAN. This formula right here, CCAN. CCA1 is this, and CCAN is this.
So you just do, what do you do? Do you just do 135,000?
No, 150,000. 150,000.
Oh, wait, you include it? So.
Yeah, well, that's a part of the base price, right? So 150,000.
And then times a third or something?
0.3 times 0.3, because D is the CCA rate is 30%. Times 0.3.
Yeah.
And then 1 minus 15%, 1 minus 30% to the power of 0 for the first one, power of 1 for the second one. But CCA1 has its own formula, right? CCA1 has its own formula. It's P times D over 2. Remember, this is with the 50% rule. If they told you to not use the 50% rule, there's just 3 other equations.
So for the first one, for CCA in year 1, use the first equation, and for 203, use the second one.
That's right.
And then taxable income, what's that exactly?
Taxable net income. Taxable net income is revenue minus CCA. Revenue minus CCA.
And income taxes is just 40% of net taxable income.
Income tax times taxable income times income tax rate.
And then what's net income? Revenue minus
net
what?
income is taxable income minus income taxes.
Net taxable income. Okay.
Net taxable income or net income?
No, net income.
Net income is taxable income minus income taxes. So this minus this.
Yeah, it's kind of a foreign concept to me because I don't be paying my tax. So it's foreign.
Just I'm just reading off my notes here. So if you go to my notes at the end, I have line by line what goes in everything. You can look there.
I'm joking, by the way, everybody. Don't report me for tax evasion.
Okay. Yes. So yeah, there's that.
I'm going to report for tax evasion now.
Okay, so question 17 is determine the disposable tax effect in constant dollars. So the disposable tax effect is when you have a difference between the final book value and the salvage value. So let's find the final book value. That's going to be this UN formula. The final book value is UN, which is in year 3. U3 is going to be the principal, 150,000. 1 minus 0.15, 1 minus 0.3 to the power 2. So let's look at this U3.
Be careful. It's not actually, I don't think it's to the power of 2. Because don't you count year 0 as 1 year? You're doing U.
Do you?
We'll find out. So you can calculate it both ways, I guess.
Yeah, the book value in year...
Oh, wait, actually, you don't even need to do the equation. Your book value is going to be the investment value minus your 3 CCAs.
That's true. Let's check if that's the same value as what we get here. That does make sense, so I would... Yeah, but let's check if that's the same thing as what I get here. Times 1 minus 0.15 times 1 minus 0.3 squared. So I get 62,475. Let's see if that's the same thing as what we get if we do what you just said. So 150,000 minus 22,500 minus 38,250 minus 26,775. I get 62,475. Yeah, same number.
So wait, why does that work? And what am I missing something? Where did the book value come from?
So CCA is the depreciation of your investment in that year, so that if you depreciate it by that value, then the other value, then the other value, then your final value is going to be like the original value minus those 3 depreciations.
Oh, okay. Oh yeah, we did a question like this earlier when I asked you if it was the depreciation for just that year or was it just for the 3 years in total, and it was the same formula, right?
Not quite the same. It wasn't the same form. It was just So like the depreciation in 1 year is DN, right? But UN or BN, which is the same thing, book value or whatever the U stands for, is just saying how much of the worth of this item do we have left, or this asset do we have left
at n years.
At n years, which is going to be the principal minus all the CCAs.
Okay.
Because the CCA is how much is being deducted each year.
Okay.
So there's our U value, and notice that there's a difference between the salvage value and the U, right? The salvage value is 80,000, and the final book value is 82,000. So that difference, exactly, it'll be, yeah, U minus UN. So the final, here, I'll write the formula. The disposal tax effect is UN minus S, so 62,475 minus 80,000, right, times the tax rate, which was 40%, right? 40% times 0.4. And so the disposal tax effect is negative $7,017. So that's going to go right here. We're going to lose $7,017. $7,017. And what that means is that, look, so our final worth was less than the salvage value. So we made a profit there. So we have to tax that profit. So we're going to remove that tax. We're going to remove this amount from the final net cash flow. So that's the disposal tax effect. So to determine the disposal tax effect, okay, in constant dollars, then I just have to turn that into, I'm quite certain, yeah, I think I just have to turn this into, no, it's $80,000 in actual dollars. Yeah, so I think I just have to turn this into constant dollars. Someone's got their mic on. Could they mute? It's a little loud. Thank you. So to convert from, we want to go from actual dollars to constant dollars. So that's going to be this formula right here. Right? Oh, I'm realizing probably my face might be blocking one of these things. Kind of. It's okay. So to convert from actual dollars to constant dollars, we do this. So it's going to be 7,017 times 1 plus 0. Now I'm quite certain this is where 6%, because this is the inflation rate. 0.6 to the power of negative 3. So $5,891 is our tax effect in, so say 7017 in well, I guess times 1 plus 0.06 to the negative 3 equals $5,891. $5,891 is my answer for that one. And let's see, net income. 7,000. Yeah, but not. That's not in. Okay, we got this. We got the same $7,017. I don't really know.
I don't think CCA changes with inflation.
It doesn't.
But does that mean your disposal tax doesn't change?
Oh, that's true. But the question said calculate in constant dollars, so that just means convert it to constant dollars at the end. I wouldn't have done it otherwise. If it didn't ask me, I would have just left it in non-constant dollars, in actual dollars. So yeah. Okay, so that's part 17, like question 17. Calculate the present worth in actual dollars. So that's going to be the rest of this. What is the inflation-free interest rate of this project? That is very easy to find at the end, I'm pretty sure. It's just, yeah, that's not hard at all. Yeah. Okay. So calculate the present worth. That means finish the table. That's what that means. So let's put our net incomes over here. I'll put the net incomes in this table over here. So that was 36,900, 29,970, 39,501. CCA was 22,500, 38,250, 26,775. And now we do well, this doesn't, nothing goes in here. So investment, that doesn't change across the years. Working capital is what we got to fill in here, right? Salvage doesn't change. Disposal, everything else is fine. There's no borrowed funds. There's no principal repayment, so that's fine. So we just got to figure out this working capital now. Okay. I don't understand. I don't know working capital. So let's see if I look at the solution here, and maybe also what the definition of working capital is. Probably be useful.
It's not too tough thing.
Can you?
Pretty
Do you know
simple.
Do you know what it is?
Oh, you want me to just? I thought you were gonna. Okay. It's basic. Well, what does it say? This one's a little different because it's a toxic question.
Yeah.
So your working capital is like, oh, how do you explain it? How was the Gervitz said it's like if you think of a cashier, you know how a cashier has to carry a certain amount of money in their thing to like pay, change and stuff.
Yeah.
But that money is always kept maintained at a specific value.
Yeah.
So think of it like it's money that it's not necessarily like decreasing, but it's usually either kept at a constant buying power, or in this case, I think it says it goes up.
Yeah, at an
by
annual
8%.
rate of 8%. Yeah.
So instead of it being 10,000 in the 0th year and like 10,000 and something in the next year, it's actually you're just adding whatever the difference is. So if it's 10,000 in year 0 and like 10,100, and that would be like if you applied the interest rate and it's like 10,000, it'll be 10,800 on it, right, or something like that. But
what? Hold on. What interest rate? If you're applying to get
not
this
interest
next,
rate, inflation rate.
Yeah. Okay.
So basically, like you're not adding another 10,000. You're just adding enough so that it matches the inflation rate. So again, you're keeping it at a constant buying power. So if it's $10,000 buying power in year 0, and it inflates by 8%, you have to make sure that there's you have to like add $100 or something to make sure that in that next year it's whatever amount.
Okay, so the idea is that I'm gonna get 8%. The value here, right here, should be 8% higher than the value here in constant dollars. But what I write here is in actual dollars.
Sort of. Basically, you can do 10,000 times 1.08 minus 10,000, and that will be like the difference between it'll be like the amount of money you have to add to the apron so that it has the same buying power. Does that make sense? Kind of?
Yeah,
maybe?
yeah, no, I understand what you mean. Yeah, it has to have the same. I see how it has to have the same buying power as 10,000. But
like if
but it's caused by inflation. So this is not a separate increase. This is the increase caused by inflation.
Yeah. It doesn't increase at all. You're just keeping it at the same value.
Oh, okay. And then for the next one, I would do 10,000 times 1.08 squared minus 10,000.
10,800 times 1.08 minus 10,800. You're just adding whatever amount you're just adding the amount needed to keep it at the constant buying power. So if you already have 10,800 in there, how much extra do you need to add in year 3 to get it to the same buying power?
Yeah,
that's for all years except for the last year. In the last year, instead of doing it again, you just take all all 3 of the previous like capital boxes and add them together.
Okay, so 10,000 plus 800 plus 864.
Yeah. So the first 3 boxes will be subtractions because it's an expense. You have to like actually have the money out there as an expense. So working capital is an expense in all years except for the last one. The last one you take all the money back.
Let me see. And that's 11,664.
This was part 18, right? Question 18?
Question 18. Yeah, question 18.
Okay, honestly, we can do it after, but I genuinely have no idea what went on right there. Like
it's a weird.
Do your magic. Explain it better than I can.
Like you guys are like, oh yeah, and then you just drop this here. I'm just like, what the? Okay,
I can explain the cashier. I can give the cashier example a little bit like better, I guess.
Sure.
Okay.
So I think if you have
before you give the example, what are we trying to do with this part of the question?
We're trying to fill in this row. Fill in this working capital row. That gets us the final the cash flows relating to like what we need here. So what is that? Is working capital.
Okay.
And
you can go now with the cashier.
So basically, think you're running a business, right? And you have a cashier that has like $1,000 change every single day. So you take that $1,000 out of your account and put it in there. And let's say a year from now, there's like 6% inflation. So you need to make sure that you add $600 so it's equal to $1,000 from before. So it's still worth $1,000 if that makes any sense. It's
So
the amount
same purchasing. You want the purchasing power of the working capital to always be the same.
To always be the same. But then you don't actually add 1,600. You just add 600 onto the money that's already there.
Okay.
Because
And
if you just have like money sitting in a pile, it's gonna go down in value, right?
Yeah.
You're gonna have to add money to it for it to be able to buy as much as it could before.
Yeah.
So the working capital is saying, how much do I have to add each time to make it so that the buying power is the same as 10,000 in year 0?
As the original year. Okay, that makes sense.
At the end of the project, you just take out all that money and put it back into your account, which is why you have the like 10,000 plus. Yeah.
So wait, so we're not. That's not that last part doesn't really make any sense because like, is it? Are you saying that the money devalues? Or are we just saying in this working capital thing? So wait,
the money
how am I
devalues,
taking? So how am I taking back that extra money? If isn't it just still technically $1,000? Like I'm not taking back their money.
$10,000?
Okay.
Think of it like taking. So you've put in 10,000, and then you had to put in another 800, and then you had to put in another $864. And then in the last year, well, you would add like normally if you're going to keep going, you would add another whatever amount of money it would be to keep it at the same rate. But you're not, because you're stopping your like the project stops. So instead of adding more money, you're taking all the money that you put inside out.
Yeah.
You don't need it anymore.
So we're removing the excess that we had put in, so the buying power could have been the same for each year.
Yeah.
Am I right or no?
Yeah.
So let's say yeah. So you have a money to buy an apple. Let's say an apple is for $1. I'm just trying to give this metaphor so I see I'm understanding or not. But the next year the apple is actually it's for $1.50, $1.50. So you will have to add 50 cents to your money so you can buy an apple.
Exactly.
Yeah.
That just made me hungry, but I think I understand. Yeah. Okay, I get it.
Okay.
Yeah, and the end you see how much you increased, and then you took it off. You take it out of your taxes.
Okay.
Is that how?
So
you take it out of
Okay, so I get that now.
Because it's not money that you're earning, or you're not earning any money on it, right? It's just change. That's why you don't get taxed on it. If that's
that's like avoiding double taxation, right?
It's increasing. It's not me making money. It's the market increasing in value.
It's the market value. Yeah. So they can't tax you.
Okay.
Right. So now our final thing is to find the net cash flow, which is just the sum of all the things after this line right here. All the rows after here down. Just add them all together. The ones that are negative, so you got to keep track of that. So net income plus CCA. These are both. Wait, CCA is.
Is the CCA negative?
CCA is an increase. You're not actually paying CCA. It's a deductible. It's why you don't pay tax on it. Like that's why you deduct it from your income.
Oh,
I see. Okay, yeah. So net income plus CCA minus 800. So it's gonna be for this first year. It's gonna be 150,000 plus 10,000. So 160,000 is the net. As a payment, negative 160,000. Negative 160,000 for year 0, and then 36,900 plus 22,500 minus 800 is 58,600. 29970 plus 38,250 minus 864 is 67,356. 67,356. And then finally at the end here we have 39,501, I think that is, plus 26,775, plus 11,664, plus 80,000, minus the disposal tax effect. That's 17.
That's like simplest part. The part with when you finish actually.
Well, pretty much, yeah. That's the net cash flows.
With the part with the net income and because like it's like three different parts: income statement, cash flow statement, and then net cash flow. The part where it has a cash flow statement and it has the net income, and CCA was that the part for part 17 with the like what did you do here again? I know that the net income was just some minus sign, right? Like 61,000 minus what now?
Yeah. 61,500 minus 24,600.
So you just brought these back down and then
yeah.
the CC,
yeah.
Oh, you just brought everything back down. Okay.
Right. This line and this line are identical, just like this line and this line are identical.
So no, I was just okay. I think I was have to review that part of it here because I was kind of confused with the like this question 17 part. Like, what were we doing for it again? There was the disposable tax
Disposable
income.
tax effect. That's this right here.
Where? Oh, this last part here.
That right there.
And we did that by what again?
By just the formula for disposable tax effect. You take the book value in the final year minus the salvage value in the final year and multiply that by the tax rate. So what essentially is happening is that if that value is negative, that means that you owe some more tax back because you made a profit on this. You sold it for $80,000, but it was only worth $62,475. So you made a profit. You got to get taxed on that profit. So that's what the disposable tax effect is.
See, taxes are just a problem. You see how we wouldn't have to suffer and the person wouldn't lose more money if taxes didn't exist.
Yes.
Gosh, okay.
If money didn't exist, we wouldn't have to take this course. So that would probably be good. I think
if it didn't exist, we wouldn't. If university didn't exist, we wouldn't be here.
Yeah. Bro, you know that there's nothing engineering about economics and engineering. Sorry, go ahead.
I give you 5 sheep, you give me 1 cow.
That was good days.
Those were the days.
Oh, the good days.
Them so well.
The good days is when you were like, hey, look, we made the wheel. It's very cool, you know. It's pretty round, you know.
Yeah, just one thing. One quick thing.
Yeah.
So working capital at year 0, we said we need $10,000, so we have the same buying power. At year 2, we said we need 800 more, so we can have the same power. At year 2, we said we need $864 to have the same power, the same power. In the constant dollar.
In actual dollars.
Yeah, in actual or constant? Doesn't matter.
Actual dollars.
Okay,
it's literally increasing due to inflation. It's actual dollars.
Yeah. In constant dollars, it would be 0, or it would be. Yeah, 0.
It would be 0. It would be 0.
That doesn't really make sense, but wouldn't it have to be 0?
I came here.
Working capital, there's no inflation, is negative 10,000 at year 0, 10,000 at year 3. That's it. There's just no change in the middle. But all the money comes back at the end.
Oh, okay. So wait, that's why we had so much at the last year, at the third year?
Yeah, because you add these together to get that final value.
And be very careful with that. You're not inflating your 10,000 again. I did that once, and I got the whole question wrong, and I couldn't figure out why.
Yeah.
It's
Wait, what do you mean?
So you don't, for year 3, there's no inflation of the capital. You don't inflate it because you're taking it out. So you, instead of inflating, I accidentally inflated the capital, and I thought, oh, I have to also add this much, but then I get it back. So I thought it was like another revenue. You don't. That doesn't exist. It's just the first 3.
It's just the first 3. Yeah.
You're
not increasing. You're not getting another. You're not making another payment in n equals 3 at year 3.
Yeah, because my year 3 revenue was $200 off, and I was like, well, that's not a lot of money, but it's where did that come from?
Okay.
Forgetting, we have eeny, meeny, miny, moe.
Let's finish answering question 18. What'd you say, Erwin?
When you are done with all the questions, can you re-explain a bit? Just go over the whole
Yeah.
Sure. When I go, I'll go over everything once.
There was I was talking about like a bunch of stuff, so like just what I need to remember.
So let's finish this question though. So question 18 says calculate the present worth in actual dollars. Well, what we do is now we know the net cash flows, right? So we just take the present worth of this in actual dollars. These are already in actual dollars, right? Yeah. So I just take the present worth at the MAR, at the 20%. I just do the present worth of that. So the present worth is going to be, negative 160,000. Negative 160,000. Plus 58,650. P given F, 20%. 20% 1. 1, and then 67,356. P given F, 20% 2, plus 150,923. P given F, 20% 3. And there we go. So I'll just do all these things, and we should get the present worth. 160,000 plus 58,006. Yep.
I was saying, I thought we did question 18 already, but still missed it.
We're still doing that.
So for Tokosoy, this might be whatever his name
The
is.
disrespect.
I don't care. I'm done. So this is gonna be on it, right? Like the exam.
I'm pretty sure.
Yeah, he said it would be.
Yeah,
that's why he even gave us the thing.
He said print it. You're gonna need
Yeah, he said print it, so we're definitely gonna give it. Honestly, he's a really bad person, and then he doesn't give us it, and it gives us something else.
I wouldn't call him a bad person for that.
I will love him.
What if he just gave us something worse?
Yeah.
I will send him a thank you letter if he did it. If he didn't know
with everybody's like signature on it? Yeah, okay.
Yeah. With like 100 roses or something. Whether they do it.
All right. Someone knows a little bit of romance right there. Okay.
Okay, I got a present worth of 22,000. What? Why 22,000? Oh, okay, I guess so. Yeah, $22,984. Let's see if that's right. Yeah, 22,952 he got. I don't know why, but some rounding somewhere. I don't know.
What interest rate did you use?
20%.
I think we have to find the discounted interest rate because inflation is also being applied. Did you go over that in your lectures though? I don't know. I'm assuming so I went over that.
Yeah, that these are in actual dollars, so taking it back, I would just use the MAR, wouldn't it? The market interest rate would take into account the inflation free.
I don't think so. Maybe. Is it you said you were how many dollars off?
$22,930 off.
Okay, then maybe it's because I think the discounted interest rate's 27.2. And the MAR is
the discount is the inflation free one, right?
No. I think inflation free interest rate of this project. I think that's just asking for IRR.
No, inflation free is asking for this. It's asking for, so we have the equation I, the market interest rate is the inflation free interest rate plus the inflation rate plus the interest free inflation rate times the inflation rate. So you see, like, the market interest rate is a function of the interest free, so not interest free, inflation free interest rate. So there's no inflation. These two terms, like, they don't have any change
I see.
to inflation, right?
Yeah,
but,
you're right.
This is inflation.
Gurvitz does it different. He doesn't give you MAR. He gives you MAR prime.
Yeah, so you need to find that. So, but this should be this would be fine. You need to use the MAR for this one because these are actual dollars. So to convert actual dollars back, you just use MAR.
You are correct on that.
Yeah. But then here. So the next part of the question is to find number 19 is to find the inflation-free interest rate, and you just do that by rearranging this. So I prime is equal to I minus F over 1 plus F, and you'd find that. So 20% plus inflation is 6%. So 0.2 minus 0.06. Someone's got their mic on again. Could they mute? It's a little bit distracting. 1 plus 0.06. So I got 13.2%. Let's get their mic on. No one now. Okay, so yeah, that's that. I think it's you, Erwin. Could you mute your mic? It's loud. Erwin?
Yeah?
Erwin, could you mute your mic? It's loud.
Oh, my bad.
It's okay. Okay, thank you.
There was another way to find the real rate, wasn't it?
What was it? Sorry.
I think it was 1 plus I over 1 plus F minus 1.
That's another way to find this interest free?
Yeah, I think the real interest, yeah.
Yeah, I forget what the real interest means. What is that interest? I only know interest or the market interest rate or interest rate?
No, the real interest is the interest prime, the prime that you have.
Prime, okay.
Yeah, not the market, the other one.
Yeah, so I keep saying interest free. I mean inflation free. Yeah, I see. Okay, well that's that. That's this question. So that's the whole thing. So yeah, let's do a review of everything that I had to take into account here with the income statement form. So I'll mention mainly the parts that were not very clear, like the parts that were a different color that we didn't expect. So the first part that we didn't expect is that revenues, they increase not at the inflation rate, but they increase at their own annual rate of 5%. Okay, because you get $80,000 in today's dollars always. That's 80,000 today's dollars, but we have to convert that to the later years at a rate of 5% because it says that the labor cost will increase at a rate of 5%. And so the labor cost is related to our revenues because the revenue that we see is really just a saving of our labor cost. So that's why these two things are related. So they increase at 5%. I think generally just think, a bunch of different things can have, I think a bunch of different things can have different inflation rates. So if you see one relating to the labor costs or the revenues, then that's what the revenue inflates at or deflates at or inflates at. And then we have another one for working capital. So working capital inflated at 8%. So that was for that. And then for everything else that's not specified, that's when you do the market interest rate. So that's why this 5% was important here. So we found that there's no expenses because that's all in our revenues. The CCA we found using these formulas right here. Applying the 50% rule because I think we always do, unless it says otherwise. Taxable net income, you do that by doing revenue minus CCA. Then income taxes is just 40% of taxable net income. And net income is going to be taxable net income minus income taxes, and that's net income. Now, just copy this here and copy this here. So from here now, we look and we say, okay, well, I need to figure out investment's already there. Working capital is what we talked about next. So working capital is an amount of money that has to always be have the same purchasing power throughout the life of the project. So from year 0, it had a purchasing power of $10,000. We put $10,000 there. It's like the money in a cash register. And so to keep that $10,000 in year 1 to have the same purchasing power, if that working capital will grow at an annual rate of 8%, as specified in the question here, we need to add to figure out this 800, we did 10,000. That's the previous year's amount, right? Times 1.08 minus 10,000. Because we just need the difference. We just need to know how much we have to add. And then for 864, we take the previous year's amount, 10,800, times 1.08 minus 10,800. And I get 864. That's how much we have to add onto it. And then in the final year, you just sum up these three and add it together. You get all the money back after. Salvage value is given to us. Disposal tax effect is this right here. It's the extra tax you have to pay on a unrecognized profit. And so the profit is because our final book value was actually less than the salvage price. So we made a profit on that sale, an unrecognized gain. And so we had to then get taxed on that, and that's what this disposable tax effect is. And then finally, net cash flow is just you add together everything after this line. The negatives are negative, obviously. So the working capital, these are negatives. I put in brackets are negatives. And everything else is positive. And then, actually, this is negative too, because you're making an payment there. And then all that together to find the net cash flow. Well, these are just cash flow. So we do P given F at the market interest rate to do that. And remember, market interest rate is, you can find the market interest rate using this formula if you're given the inflation-free interest rate and the inflation rate. You can combine them to find the market interest rate. And that's what you need to bring everything back to year zero to find the present worth or do any kind of analysis with. Okay, there is that. There is that question. So, well, yeah?
No, I'm just saying life is good.
Life is good now because you can do this? So, let's finish. Yeah, go for it.
I'm sorry, it's still not good until we're done tomorrow. Then I will not have to do it in my.
That's when I'll be good too. Yeah, that's when I'll be good too. Okay, so we got about 10 minutes left or 7 minutes left. So I don't know. Do we have any more questions we want to do in the last 7 minutes, or any questions about this that I can answer, or anything like that?
No, because like I feel like it's too much to speed run the last 2 questions. Because honestly didn't keep up. I'll just look it over afterwards.
Yeah. So
ECN is depressing, man.
It's a lot. It's a lot.
And it's like there has not been any engineering in ECN. It's just if the most we've seen is a question with the word engineer.
Yeah, they just make it engineering topics.
No, bro, but
so
but listen. But
so
that
sorry, someone's gonna say something.
Yeah, I was wondering. D is the same rate as 30%, right? The same MRA.
I swear I heard another voice.
D is?
D, yeah, with the D that you use here.
Oh, no, it's not the MAR. It's the D is the CCA rate, 30%. Oh, is that what you said?
Yeah.
Yeah, so it's 30%. Yeah, it's 30%. It's not the same as the MAR, though. The MAR is 20%.
Oh, yeah, I'm sorry. Yeah, they give it in the question, right?
They give it in the question, yeah.
Fun fact about this course, by the way. Apparently, it used to be one of the last courses you take in your final year at the university, but too many people were failing it.
Oh,
yeah, I mentioned that once before.
You don't want to say something like that.
They dialed it down because they put it in first year. People used to be failing it, okay? That doesn't mean we are now. None of that.
All right. We don't do those. We don't do that here.
Jonathan, I asked that fun fact. I asked Garvis about that fun fact, and he said he doesn't know about any. He had never heard of that before.
Yeah, really?
Yeah, okay, Garvitz. Okay,
yeah,
Garvitz.
Garvitz is either covering up the mistakes of the department,
or he wasn't
looking out for your mental health. Toxo is out here trying to fuck it up.
Yeah.
Toxo is very cheerful though. That's the thing though. Like you never suspect that Toxo is a difficult professor because he's just like, okay, let me know if anything's wrong, and you're just like, everything's wrong, man.
Yeah.
Everything.
He said, let me know if there's anything wrong.
Someone's on a motorcycle or something right now.
Yo, Adam.
I live beside the highway, so like.
Oh, okay.
If my window's open to like not have my room overheat,
I
just hear the motorcycle.
Adam, for a second when you put your earphones on, you put the earphones over here. It's a new look. Like I was like surprised.
Oh, like
for a second.
Put it like this.
Put the here like behind.
Like that.
Yeah, I was like, there's a new guy right there.
Really?
The quarantine here. Yeah.
Yeah, gotta.
Jeez, Adam's different.
I'm just wondering about the disposable tax effect thing. If you scroll down a bit.
Yeah. More? Oh, disposable tax effect here. Yeah.
Yeah, so it says you wrote like is equal to 5891, but at like in the box up there you have 7017.
Yeah.
Is it that?
This is the disposable tax effect. That's what I got out of disposable tax effect. It was asking for it in constant dollars though. Constant dollars, which just meant I have to turn it into constant dollars. Like I turn it into your $0. That was this process. That's the actual answer for number 17, but the disposable tax effect is in actual dollars, and that's the number we use.
Oh, okay, perfect. Thank you. That makes more sense.
Bro, the funny part is I'll never use this because I never pay taxes, so I can't use this anyway. But, like, pretty much doing your taxes,
it's too bad. I mean, this question doesn't have any. I mean, it's not bad, but it's bad in terms of practice. Like, you don't have any expenses or anything like that, or debt interest. Like, we didn't do anything that has to do with debt in this question.
Interest, yeah. That's
So
some more calculations there.
You might want to look at a question that shows that.
Yeah.
Or just use whatever Adam has in his notes.
Let's not worry about the debt thing right now. This is enough stress.
Yeah.
I don't know.
This is a fourth year course, let's say, if they canceled from you, or did they notch it down a little bit? Or not notch it up or something?
I don't. Did they? You mean like? Did they change it from the fourth year course? Did they like?
Yeah.
I don't know.
Or
I don't know.
the same.
Does anybody have any
Like
idea?
guys who were okay.
I don't know. That looks like I don't have an answer.
Still like a hell.
Yeah.
It's
Oh,
very
but,
so bad.
I don't know, but everyone, I asked Gervitz, Gervitz tell me, or I think he was saying in the class how this class is important because when you're an engineer, you have to get cost-effective solutions to problems. So like, you need to know how to like understand money. You can't just come up with a bunch of science and like, there you go, and the product is like 20 million.
Guess so.
He meant that as in like when you're if you're an engineering team leader or a manager of engineers, you might have to do that. Like that might actually be part of your job. But I don't think if you're working in a team at some company, you're probably not the one deciding on what projects you're working on.
No. Yeah. I would say no.
You might eventually, but like it wouldn't be something you're gonna do right away.
I feel like these skills are the type of skills you learn when you're actually working at a job. Like, there's like skills you learn in school, there's like skills you learn on the job usually. I feel like this kind of tends to be one of those things you kind of learn as you go on the job,
I guess so. If you needed to do this as your job, yeah.
Like plus people don't remember in 4 years.
Accounting firms and stuff like this. Accounting firms and stuff like this to do this kind of job for like engineering companies and like contractors and stuff like this.
Yeah, the sad part is I'll actually need this year because I want to start my own firm, so like I actually might need this, sadly.
Well, you're not a business with operation and management fees and debt interest, hopefully. Well, I guess some kind of debt, but salvage fees and everything like that. So it'll be a little different.
The debt interest is my tuition.
Yeah, that's why I said, well, I guess kind of debt, but yeah. But that's even like that doesn't even work the same as this kind of like debt, so.
They should teach us how to do our own tuitions and how much in debt we will be in the end of the fourth year.
Have to pay taxes, but they don't. It's just like go figure,
Thanks, Adam. Thank you. Have a good night.
No problem. Yeah, we're done. For everybody, we're done now. So yeah, have a good night. Good luck tomorrow. Send me any questions if you have them. I'll.
You guys got this. You just need to pass this exam, and you pass the course.
Exactly. That's it.
As long as you didn't fail literally everything else.
Yeah, that's a problem.
No, actually, if you passed it, even if you did fail pretty much everything else, if you did reasonably well on this one,
it's getting weighted over time.
You'll be able to do it. Yeah.
Adam, I hate to drag you back into this, but in the discussions tab, so I'm still hung up on the 5% that we had for the question 16 that we had basically for this entire chart.
Yeah.
So I understand where the 80,000 comes from. I understand how that should get adjusted, but in my head, a 5% increase in labor cost, meaning taking away from savings, is the way I see it, would result in less money, not more.
Yeah.
So why did it result in more?
It would result in less money. This is what it is. It would result in less money in today dollars. Right? So if I were to convert like 88,200 to year $0, we would get, let's see what we would get. 88,200. If I convert that to, I'm going to bring it back by the inflation rate, which was 6%. So it's going to be 1.06 to the power, what did I say? I said 88,200. So bringing it back 2 years, right? That's $78,000.
Oh, okay. So it did do that right. Okay, thank you.
Right?
Thank you.
So does that make sense? Okay, good. I'm happy. So it did go down. Our profit went down. It's just that it went down in current dollars. Right?
Yes, sir.
Not in. So it had to go up in actual dollars.
I guess there's a reason these questions are going to be worth multiple marks because it really is like a long process just to do one of these.
It's a long process.
Yo,
Well,
honestly,
if you can see the whole test, like if there's no like blocking, you can. I guess you could do this question first if it is worth more points than all the other ones.
Yeah, you could.
It's a good strategy.
I really hope we have some just like he gives some just easy ones, just like
I
easy
feel like
you can grab ones.
I feel like this would be like a bonus, or is that not?
Oh, you
Cause
feel like you'll do the bonus one?
Yeah, I feel like it'd be a
No.
bonus.
No, his
Grove is doing a bonus. I don't know if it's
his
the same.
bonuses are like 1 mark at
So,
best,
like-
and this is not a 1 mark kind of question.
Like if this was a bonus mark, I wouldn't do it.
Yeah.
I probably wouldn't do it.
Like the bonus is usually something a little obscure, but that still draws on the knowledge that we have.
Yeah.
I feel
like
like
using a formula
that's
in a weird,
literally
weird
this.
way.
That's literally the income statement thing.
Yeah.
Fair.
You're describing that. I don't know. I feel like that would be it.
Alright, guys, don't wake up tomorrow and forget about the exam that is like a Saturday morning. You're like, ah, great day today. And you're just like, wait, something, I feel like something I'm missing.
Something at 9 o'clock.
Yeah. Actually, about that, can we get an admin to just like at everyone real quick before the exam starts?
Just ping everybody. So
Bold
would
of you
that
to
wake up
assume-
anybody?
Bold of you to assume that the admins are gonna be up any earlier than us.
Yeah.
Hey, set
Yo,
your
I can-
alarms.
If you guys want, I can add everybody about the exam.
I don't.
What
well,
time?
don't add everyone because the upper years will also be pinged. But here, it was just
Should I
announced.
send-
Yeah.
Should I send an announcement?
Well, right now in announcements, there's an announcement. Someone just posted an announcement. Oh well, no, not just now. Sorry, at 5 o'clock. So posted an announcement. But
You know what? We'll be fine. This is what engineers do. We somehow will be fine. Which is when have we never? All right, guys. I'll see you.
Okay, I'm done. I'm done for now. I'm gonna stop recording.